Engineer Pat? Hello?
Naririnig naman po, ma'am.
Okay. Akala ko nasa iba na naman akong planeta. Okay, magsisimula na tayo. Less than 1 minute.
Okay.
Sound check.
Mag-start video na rin po ba ako?
Okay, Jessica.
Hmm.
Okay na?
Okay na po. Hi everyone, good evening po. Maayong gabi sa inyong tanan. Magandang gabi po sa ating lahat. So welcome to our second webinar brought to you by IECEP Mindoro chapter. So to start our this webinar, right, let's have first our national anthem.
Tumayo po tayong lahat, ilagay ang kanang kamay sa ating dibdib at sabay-sabay nating awitin ang pambansang awit ng Pilipinas.
Bayang magiliw, perlas ng silanganan, alab ng puso, sa dibdib mo'y buhay. Lupang hinirang, tuyang ka ng magiting, sa manlulupi, di ka pasisiil, sa dagat at bundok, sa simoy at sa langit mong bughaw. May hirap ang tula at awit sa paglayang minamahal, ang kisap ng watawat mo'y tagumpay na nagniningning, ang bituin at araw niya kailan pa may di magdidilim. Lupa ng araw ng luwalhati pagsinta, buhay ay langit sa piling mo. Aming ligaya na pag may mga api, ang mamatay ng dahil sa'yo.
Yes, so good evening po ulit sa ating lahat. I'm Jessica Atienza. I will be your moderator for webinar. So, may mga from other side of world tayo dito. So, good afternoon po, good morning po sa inyo dyan. For tonight's webinar, we have first, may we have Engineer Alvin de Guzman for our house rule for this second webinar. He is our IECEP Mindoro Vice Governor Internal. Good evening po, Sir Alvin.
Hello, good evening, Ma'am Jessica. Thank you
Yes
so much
po.
for that
Good evening
introduction. Okay, and once again, welcome everyone sa atin pong second webinar. Kahit papaano, nakaka-utay-utay din ang IECEP Mindoro. Ano po? Maraming salamat po sa mga sumusuporta hanggang ngayon. Marami na tayo ngayon, nasa 76 na. And also, I would like to welcome also yung ating mga VIP. Si Dr. Detalya, nandito na rin. So yung iba pa natin mga BEC, maybe a bit later, nandito rin sila. Okay? So let's cut the chase and let me present to you the house rules. Share ko yung aking screen. Okay. So for our house rules, okay, all participants must register using the link that we have provided in our Facebook page. Again, the registration is open until 7:30 p.m. only ngayong gabi. So mag-register na po kayo yung mga hindi pa nakapag-register dyan. Participants can send their questions throughout the course of this webinar using the Q&A section in Zoom as well as the comment section in our Facebook Live. Okay, so i-avoid po natin na i-message directly yung speaker. Doon tayo sa Q&A portion ng Zoom mag-raise ng questions. Next, the questions will be answered in between breaks and at the end of the presentation. We will, of course, try to accommodate as much questions as we can within our limited time period. In order to receive an e-certificate for this webinar, participants must cover at least 90% of the webinar, fill up the attendance form, we will be providing the link later, and also fill up the evaluation form at the end of the webinar. Again, the links will be provided later. And please note that the evaluation form will be available until midnight, 11:59 only. So hindi na natin ipapagpabukas yan. Gawin na natin mamaya pagkatapos ng webinar. And finally, the e-certificates will be sent to your email addresses as soon as they are ready. Okay, so those are our very simple rules. I'm sure everyone is excited na. So let me turn you over back to our host, Ma'am Jessica.
Thank you, Sir Alvin, for that house rules. So to continue this webinar, let's have Engineer Ornan Vicente, our President of the Federation of Rapid Emergency Telecoms team, for the presentation of IECEP Mindoro officers. Sir Ornan. Hello po, Sir Ornan.
On behalf of Sir Ornan Vicente, this is Gerard Tan. I wish to honorably present the 2020 officers of the Institute of Electronics Engineers of the Philippines Incorporated, Mindoro Chapter, with accreditation number 33. We wish to present the immediate past governor, Engineer Wilfredo Napoles. The following are the trustees of the Mindoro chapter: Engineer Lordelisa Anyayahan, Our trustee is also Engineer Jimson Ang. And another trustee is Engineer Richmond Marasigan. Another trustee is Engineer Jibe Esau. And another trustee is Engineer Irv Magmanlak. Another trustee is Engineer Adrian Paul Abelia. Another trustee is Engineer Christopher Go and their auditor. And also our treasurer is Engineer Humphrey Dolor. The chapter secretary is Engineer Kimberly Joy Corona. I wish to present also the Vice Governor for Education, Engineer Gerald Chokson. Of course, our Vice Governor for External Affairs, Engineer Patrick Georgian Hulipas. The Vice Governor for Internal Affairs, Engineer Alvin de Guzman. And no other, the Governor is Engineer Donna Angeline Valdez. Thank you very much.
Thank you po, Sir Gerard. Right. Thank you for that presentation, sir. So, we have some raised hand from Miss Evren Love. Yes po. What's the concern po? Wala po bang concern? Okay po. To continue, may we welcome Engineer Donna Angeline Valdez, our Governor in IECEP Mindoro, for her welcome remarks. Thank you, Ma'am Donna.
Hello, good evening. Hello, everyone. Thank you,
Good evening
Jessica. Good evening to all our guests and participants for tonight. Kamusta po kayo? We hope that you are all safe and healthy. Tonight is our second webinar, and it is under the Telecommunications Track of the Online Technology Summit. And we are happy to share with you one of the most in-demand topic in communication, the fifth generation technology or the 5G. But before we start, let me welcome our guest speaker for tonight, Engineer Derek Dimla. Thank you, Engineer Derek, for your generosity. We are so blessed to have you here. And thank you for choosing IECEP Mindoro to be your avenue to share your expertise. Welcome again to IECEP Mindoro. Also, it's our privilege to have here our Board of Electronics Engineering. They will encourage us professionals, and later they will update us in some important information with regards to our profession. Let us all welcome Dr. Alnar Ditalia, Engineer Enrico Claro Del Moro, Engineer Herminio Orbe. Thank you po for being with us tonight. This webinar will never be possible without the help of the people behind the Radio Engineering Circle, our extended family, Engineer Ornan Vicente, Engineer Gerhard Tan, and our very own Engineer Patrick. Really, thank you very much, and welcome po muli sa IECEP Mindoro. Of course, to all the IECEP Mindoro officers and members for your unending participation and support. Stay healthy, co-engineers. Welcome and thank you very much. Again, sa lahat po ng participant natin tonight, sa Zoom, sa FB page, sa FB Live, especially those from other chapters ng IECEP, welcome po, and we hope that you stay tuned until the end of this webinar. Again, maraming salamat po. Back to you, Jessica.
Thank you po, Ma'am Donna, for that warm welcome remarks. So, to give us some inspirational message, we have Dr. Alnar Ditalia, our chairman of the Board of Electronics Engineering. Uh, Dr. Alnar,
Hello, good evening.
good evening po.
Uh, how's my audio? Okay lang ba?
Okay naman po.
Okay po.
Yeah. Good evening to all of you. And again, it's a very interesting topic na naman at stake for all of us tonight. And so, as what mentioned, what I mentioned a while ago, in demand na topic ito. So I hope that everybody should listen and learn from our speaker tonight. My congratulations also for the officers of IECEP Mindoro for coming up with this activity and the topic, choosing this particular topic in telecommunication track. So I guess this is prelude for more topics in telecoms in coming. Uh, so once again, I hope everybody should listen and learn from this lecture. Good evening. Thank you.
Thank you po, Dr. Alnar, for that inspirational message. So, without further ado, for the introduction of our speaker for tonight, may we have Engineer Gerard Tan, our Director from Globe Telecommunication Incorporated. Sir Gerard, good evening po.
Hi, good evening. So welcome everyone, and tonight we have a spectacular distinguished speaker who's gonna share his expertise in the field of telecommunication specific to 5G. He had been also one of the top-notch engineer as he graduated cum laude during his college years, and likewise also been working with Globe Telecom, leading the technology innovation of Globe. So he is, without much ado, he's a good friend, an able engineer, expert to this topic. I wish to honorably present to everyone Engineer Derek Dimla.
Hi, good evening, everyone. Can you hear me, Sir Hard?
Yeah, loud and clear.
Thank
Good
you,
evening
Sir Hard, for that
po.
wonderful, introduction. And I wish to thank ISEP Mindoro as well for inviting me here, and to our distinguished board of directors, Sir Ornan, no? Sir Del Moro, and Sir Ditalia, and of course to Ms. Donna for inviting me here. Thank you so much. Sir Hard, thank you as well for the introduction. So good evening. I hope everyone is safe. If you cannot hear me, no, just let me know so that I can adjust the volume, the settings of my computer, so that you can hear me clearly. And just to remind everyone, no, based from Sir Alvin's house rule, we have that 90%. You should be saying for the presentation for almost 90% of the time, and just checking on the deck, no, it may take us 2 hours. So kailangan nila mag-stay na 1 hour and 48 minutes, Sir Alvin, tama ba? Para makakuha ng certificate. No?
Tama po, sir. Tama po.
Yeah, so pero biro lang, no, you have to tignan natin ang magagawa natin, but I have a presentation here. Let's run through it, and then if you have questions, we can put them later in the discussion. So tonight's topic, again, it's very hot, and I think it's also. Can you see my screen? And it's
Yes, sir.
deployed internationally, and we're coping up as well from Southeast Asian nation. So, uh,
Excuse po, Engineer Derek.
yes,
Medyo maingay po ata yung electric fan or
wait,
tas medyo mahina rin po yung audio.
yan. Can you hear me now?
Okay po.
Clear ba? Clear?
Yes po. Much
Okay.
clearer po.
Okay. Clearer. Can you see my screen?
Yes, sir.
Clear then? Clear.
Ako.
Okay. So let's go. Okay, so the points of discussion for tonight will be, number one is everything wireless. Now, you have to discuss a few topics or a few things about wireless technology. Just have to get through this one. And then we have to talk about standards. And why 5G is a standard, later we'll discuss about that. And then, of course, a 5G basic. Have to learn the fundamentals of 5G, maybe the key technologies that are foundational to this topic. You know. So let's just have a view, an overview on how the internet works. So basically, you have an application. So madami sa atin, no? We're doing a lot of applications, both for mobile, for our laptops, and most of the time, lalo na ngayon, naka-stay at home tayo, nag-Netflix tayo, nag-YouTube tayo. So we always have to start with the application. And of course, from the application, it will generate a request to the user equipment or yung phone natin, yung computers natin, then it has to connect to a certain modem. Okay, if you're using a phone, your phone is a modem as well that can connect to the access facilities from the internet service provider. And from the access facilities, both it can be wired and wireless. No? Pwede yan bumuga ng wireless over the air, or it can be passed through mediums like cable na fiber or coaxial. So now, from the access facilities, it will now go to the core network where doon nangyari encrypting, coding, routing, and then pupunta yan palabas ng bansa to the application server. So yung mga application servers natin can be Facebook, it can be as well yung YouTube, no? Sa iba't ibang across regions sa buong mundo. And then from there, pag naka-request tayo naka-request tayo ng information from the application, then yung server na yon from different parts of the world will send back the information to the ISP core network, back to the ISP access facilities, the modem user, and then to the application, where your data will be processed and be displayed into an audible information or something that can be shown or can be displayed, yun nga, mga images natin. So if you try to understand it, everything happens in a millisecond time. And alam naman natin, no, pag humans can only understand seconds or second, no, as a smallest unit of time. Siyempre, di mo pwedeng sabihin na, oh, friend, kitain kita sa mall in 30 milliseconds. No? It's really impossible for us to do that. Or let's say, sasabihin mo ba na, oh, friend, we'll meet at 3,700 milliseconds. That would be impossible for us to calculate, lalo na kung mental mathematics ang gagamitin natin. But if you would tell him or tell her na, oh, let's meet in an hour, that would be 60 minutes, no? Or 60 times 60, that's 3,600 seconds. That would be possible to calculate and to understand. So it's an easy to understand na application, going to your phone, going to the modem, or going to directly to the access facilities, going to the core application, then back. And it happens in millisecond time. Now, 5G is a wireless communication. You know that, or if you don't know about it, so 5G is a wireless communication, meaning it connects to our base station. It connects to our towers through wireless technology. And alam naman din natin that only you can connect to the 5G site if you have the 5G device. And alam naman natin, because if it's wireless, it's something that we cannot see. Tama? But for 5G, since this is a wireless communication, in that wireless communication channel or wireless communication link between your phone and the site, there must be some link between them, no? Or what we call the channel. Same thing, no? Pagka meron kang tangki dyan at meron kang glass dyan sa the midday sun or midday noon, no? Mauhaw ka. And then if you want to get water from a particular town or particular container or reservoir, no? You need to put a pipe for it to release some water coming from the tank. And kung halimbawa, kung glass yan, let's take it for example, yung application mo is a glass because you want to drink water, so you'll be using glass. If you want to water the plants, then you need to get a pail, no, or a hose in particular. Ngayon, yung relationship between them, then it has to have a link between the two. Tama? And to pass through the water from one point to another, then that channel has to be established. Okay, ano sinasabi natin dito is that pag once na inopen mo yung valve or inopen mo yung pass through mo from that pipe, no, it will start to go down from the tank or from the tank down to your glass. Kaya napupuno yan na napupuno. So now, if I have to ask a question, no, everyone can participate in this question. Baka mamaya may pa ano yan, may pa cash prize si IECEP Mindoro, kidding aside. So if the water tank has 20 liters of capacity initially and the glass water was filled up, full at 5 seconds, the remaining water in the tank now is 15 liters. So what is the rate of water release? So I'll give some time para yung mga participants natin can think about this one. So question is, what is the rate of water release? So kung if somebody can give an answer, you can just put it in the question and answer chat. So 10 more seconds. Okay, up. The answer is, ano ba tayong sagot? Wala, no? Wala ba sumagot sa chat? Yun. Meron. 1 liter per second daw. Tama ba yon? What do you think? So, ang tamang sagot ay, may sumasagot Okay. So, if you try to calculate now, the glass capacity is 20 liters minus 15 liters. So, the capacity of the glass would be 5 liters. And sabi natin, napuno siya in 5 seconds. That's why the correct answer is 1 liter per second or 1,000 milliliters per second. Tama ba yung mga sagot natin, Miss Jessica? Yun, tama, no? Meron tayong answer from Donald and it says...
Si Sir John Carlo.
Yan, tama po tayo. So, ibig sabihin, if we're passing or pagka naglalagay tayo or pagka nagpapasa tayo ng water to the glass, no? It has to have a relation to what we call the time. Okay? And alam naman natin when we're talking about speed, meron tayong relation sa time. So kung gaano kabilis, kung gaano kabagal, meron yan. Kaya nga sa mga sakyan natin, we have that odometer that reads, sabi niya na you're getting, let's say, 60 kph or more than. Okay? So clear yan. Now, for the case of wireless communication, no? Sabi niya, can you see wireless communication? Can we see wireless communication ba? Can we hear wireless communication? No? Yung mismong connection between yung kung sa glass at saka sa tank at saka glass communication or sa relationship yan, we'd be able to hear it, smell it, taste it. The answer is no, but we can really measure it and experience in our day-to-day digital application. How? So I can show here some of the devices capability to measure yung mga signal measurement natin. Okay? So if you have the Samsung phone, no, you can just type. Can you see the numbers ba or am I blocking it? Let me adjust this bar. Okay, there you go. So yan, no, if you try to check it using your Samsung phone, asterisk number sign, 0011 number sign. So you'll be able to see this one. Meron kang mga measurements yan. Meron kang numbers na makikita. And usually meron tayo tinatawag na RSRP dyan. And even yung SINR, bandwidth, no? Makikita natin yan dyan. Okay? Meaning, you are able to, if you have this type of measurement, then you'll be able to request a link from the site going to your phone. Because this is your phone capability, this is your phone measurement. You get my point? Now, for iPhone, no, you can type number sign 3001, number sign 12345, number sign asterisk, and then you just have to dial it. At pag lumabas yan, no, makikita mo din dyan yung sa LTE MEAS or LTE measurement, yung mga ganyang values. So yung mga values na yan, they tell us something. They tell us about the power and the quality. So RSRP would basically mean reference signal received power, and your SNR would be signal to noise interference ratio or signal to noise ratio. Pagka SNR, pagka SINR with the inclusion of interference, which is the SINR for other phones. Okay? So nasubukan ba natin? I'll just have to check with the chat, no? Meron pong app na mag-measure ng network cell info light. Yes, we have. I think it's called the GNet tracker. No? You can just download it through your application and you will see some of the information as well. Okay, tama po si correct. So I think some of the people in this webinar are from the telecommunications field as well. No, it's good to know that you're from the field as well. So welcome mga kabayro sa ating discussion for tonight. Okay. So ibig sabihin measurable. Kaya lahat ng mga ginagawa ng technology, no, particularly sa wireless, we can measure that, and even your wire can be measured. Yung information natin that are passing through the cables, na measure din natin yan, no? Meron din tayong ginagamit, and even our modems can measure those things up. Okay? Clear ba? Clear? Hope, no? Pa-thumbs up na lang ako pagka clear. Okay? If not, let me know. Okay. So tuloy tayo. Yan. Okay. Sorry. Yan. So now, what is 5G ba? Okay. And how is it related to 3GPP, no? Okay. Usapan natin yan. 5G is a 3GPP standard. Okay. And 3GPP composes of a lot of operators and organizations that does yung ating standardization. So we have 3 core groups when we're looking at 3GPP. Okay, 3GPP would mean third generation private and public-private partnership. And it composes of 3. Meron tayong tinatawag na RAN, or which is what we call the radio access network. Then we have the CT or the core network and the terminals. And then we have the systems and aspects. So meaning, ang sasabi natin dito, no, they have to work hand in hand to generate yung tinatawag nating 3GPP standard for whatever technology they have to develop. And 3GPP started even from 2G phase pa. So meron tayong GSM, GPRS, EDGE, WCDMA, HSPA. Yun yung mga lumalabas sa mga phones natin, no? Pag lumalabas dyan, E, that would mean EDGE. Pagka H, no? 3G, HSPA+, pagka H+, pagka lumabas LTE, definitely LTE yon. Meron pang LTE+, and so on and so forth. So makikita natin, 3GPP has 5G as well. And this has been part of the generation development since for mobile or cellular communication. At itong tatlong to, si radio access network, si systems and aspects, si core and terminals, no, sila yung nag-uusap-usap to release yung tinatawag nating technical reports and specifications. Kaya meron tayong tinatawag na later na makikita natin anong mga releases yung mga yan. Okay? Clear. Ayan, pa-like. Salamat po sa mga likes, no? Okay. At least I'm making myself clear. Kasi kung hindi clear, no, we have to. So ngayon, again, more than technology ang 5G, no, we have to understand that it is a standard first. So kailangan mag-set muna ng standard or ng specification ng technical reports. Itong tatlong to, sila radio access network, sila core and terminals, sila systems and aspects, bago tayo magkaroon ng standard. Okay? So ngayon, makikita natin on the right side, on the lower part, 2G, 3G, 4G, and even 5G, pataas ng pataas yan. The technology goes up, the timeline goes to the right. So ibig sabihin, habang syempre may mga vision sila na by end of 2025, by end of 2030, syempre iniisip nila ano ba yung magiging roadmap ng technology. And all of these things are being adopted by our local telco as well. So nandiyan sila dito, sila Globe, sila Smart, no? The first things first, if you want to deploy such technology, then the network should be capable first. Okay? Kailangan yung network mo umaandar. Kasi kung wala kang network, then definitely, paano masabihin na meron kang 5G coverage? Second thing is the end-to-end system won't be able hindi siya pwedeng tawagin na system na end-to-end if you don't have the device. Kaya dapat meron sila Apple, sila Samsung, sila Huawei, no, ng devices that would be able to support yung technology na to. And the network, of course, na meron tayong tinatawag na registration to the telco. At pag nag-register ka sa telco, no, you have to avail some of their products. Kaya kumukuha ka ng SIM card, no, or your SIM card that is currently, let's say 4G, it have to be upgraded to 5G before you can actually go to their network. And of course, the whole system, no, is being governed by the National Telecommunications Commission, meaning hindi tayo pwedeng magpabuga ng basta-basta ng wireless technology. Tayo pwede magpadala ng data over the air using cellular frequencies, using cellular spectrum without NTC allowing us or NTC licensing us to use such frequencies. Okay? So kung walang frequency, walang 5G. Kung walang device, walang 5G din. Kung walang network, walang 5G. Then these three has to have or needs these three, no, need to work hand in hand as well para yan. Thank you for the input, no, from Engineer Michael, no. Correct ka dyan. The device, if you run them commercially in the Philippines, you have to get NTC approval as well. No? Dumadaan din yan sa tinatawag nating type approval. And even not only the devices, network elements, they need to be type approved before we can deploy them. Okay. So, system. So, yung tatlong yan, nag-usap-usap sila, RAN, sila core terminal, mga devices, at saka yung core functions, si radio access network, yung access technology, gagamitin ba natin wired, wireless, or anong type ng medium, or optical ba, no? Sila SA naman, yun yung mga systems and aspect, and ano bang gagamitin type of multiplexing, gagamit ba tayo ng TDD, ano bang gagamitin na coding, no? Pinag-uusapan nila yan. Okay? Kaya lumalabas yung mga tinatawag nating technical reports and specifications. So, ano ba nangyari dito sa 5G na to? Again, ang 5G ay standard na create nila with search visions, and of course, meron din sila tinatawag na target. Siyempre, pagka gumawa ka ng batas, no, you have to have a goal as well. Kailangan magkaroon ng ano ba yung vision mo? Ano ba yung vision mo for this type of development, no? And makita natin dito na baka mga confused lang kayo. There is this IMT 2020 vision, and IMT is an international a group din, no? That's being run by ITU. Okay? ITUR, at yan ay nakikipag-coordinate with 3GPP. Sabi natin kanina, the organizations of 3GPP, iba-iba yan. So meron tayong ATIS, ARIB, ETSI, TDSI, TTA, yan mga nag-usap-usap sila, and they have a project coordination group that relates to ITU or International Telecommunication Union, no? Si ITU meron siyang vision for 5G. At by 2020 gusto nilang i-release yung specification na yan. However, no, makikita natin diyan so, bago tayo pumunta doon, no, makikita natin dyan, yung radio access network, no, RAN, radio layer 1, 2, 3, 4, makikita natin yung mga lahat ng ilalagay nila. No? Networks terminal, and then SA. So, ito yung tinatawag nating technical specification groups from 3GPP. Okay? So, nakipag-coordinate yan with ITU kung ano yung standard na gagamitin. That's why, no, if you try to look at the comparison between the ITU and 3GPP, so si IMT, meron siya, or si ITU, meron siyang IMT 2020 na vision. So, ang target nila is to release the 5G by 2020. However, 3GPP being one of the known organization or known body that has a lot of organization to develop yung mga ating cellular technology, they were able to have this release, no? Yung 5G first release natin, lumabas siya sa release 15. Okay? Kaya dito lumabas yung ating 5G phase 1. So instead of having it by 2020 specifications by ITU, makikita natin na naglabas na si 3GPP ng mga specifications during this time. Okay? So meron silang study back in 2016, and then they released it during end ng mid 2018 up to end, no? And even yung release 16 natin ng 2019. Okay? So nandiyan si 5G phase 1 tsaka phase 2. And I think no, meron din tayo mga next releases pa na makikita. However, because of the pandemic, yan, natigil yung kanilang mga face-to-face discussion. Kaya zoom din muna. I think na they release some specifications as well. You can check that out. This link, no? 3gpp.org about 3GPP. Okay. So now makikita natin, no, ito yung target nila. Okay? Ito yung IMT target. Makikita natin sa graph na to, let's say for data peak rate, no, ang target ni IMT 2020 is 20 Gbps. Okay? How to read this one? You have the number, you have the value or the unit. So for user experience data rate, no, 100 to 1000 Mbps data rate, and then spectrum efficiency 2, 3, 5. Okay, mobility, ganyan, and so on and so forth. Latency 1 millisecond, density and 10 raised to 6, that's 1 million, and network efficiency. Now, makikita din natin dito that IMT Advanced is somehow related to tinatawag nating LTE 4.5G or tinatawag nating LTE Advanced Pro, wherein ang target na is to have a 1 Gbps data rate, 10 Mbps of na user experience rate at saka yung ating spectrum and so on and so forth. So ganyan natin binabasa yan. Okay, so makikita natin that there's a bigger requirement for IMT 2020. Okay? Clear pa so far? So ito yung naging evolution ng 5G. Now, how do we realize 5G for end users? So 5G is wireless na, it works on frequency, bandwidth, and antenna. Okay, so again, 5G has shorter coverage. Later, pag-usapan natin yan. Increasing tower height may help, but adding more towers too. Okay, so kaya I think most of the telco now are really into running more works with the government, no, to deploy more towers, to deploy more coverage to help our subscribers get yung ating service for cellular communication. Okay, these are not 5G. Pagka kinonfigure mo yung Wi-Fi mo, makikita mo diyan meron siyang 2.4 tsaka 5G parameters. So, let's say pinangalanan mong kabit Wi-Fi yung 2.4 tapos Wi-Fi de kapitbahay yung yung sa 5G, no. This configuration for 5G parameters is not 5G, okay? It is 5 gigahertz of frequency. And 5G is a 5th generation technology, okay? It's a 5G or 5th generation, no? 2nd generation, 3rd, 4th generation. This is not 5G, okay? Clear na? It's not the 5 gigahertz frequency that you read on your modem or on your Wi-Fi configuration. And lalong-lalong naman dito, hindi ito yung Biomax 5G na panlaban daw sa mga, di ba? Panlaban dun sa binabato na 5G signal, no? These are not 5G. Okay? Clarify ko lang yun. These are not 5G. Now, how do you realize, again, 5G for end users? Of course, we have the key technologies and specification application. And later, no, in between this one, the system, makikita din natin kung ano ba yun. Okay, so some of benefits of the 5G, no, it has a higher throughput, it has the increased capacity and quicker response, or what we call the latency, which has been discussed as well on the previous, and it has, of course, sabi ko nga sa inyo, dapat maglagay tayo ng target. Ano ba yung target natin for 5G? So ito yung target natin na throughput, 10 Gbps, 10 raised to 6 or 1 million devices per square kilometer, and a quicker response that is, or latency, what we call 1 millisecond. So now, baka malito lang kayo, bakit po merong ganitong target si IMT? Bakit kung 20 Gbps ang target ni IMT, bakit 10 Gbps lang ang target ni 5G? Again, kung titignan natin dito, these are two different specification. Si ITU meron siyang vision to have a 20 Gbps, but 5G 3GPP has proposed and released yung mga specification nila based on their testing, based on their studies and all specification na 10 Gbps pa lang ang kaya nilang i-target. Okay? So ngayon, dito yung current na target ng 5G natin. So 10 Gbps throughput, increased capacity, and then yung ating latency, which is 1 millisecond. Okay? Now, let's start with device specification first, no? Kasi ito yung I think, most important of all. Particularly pag sa end user. Kasi we're trying to realize here yung ano ba yung magiging benefit niya sa user, no? First things first, the device has to be capable of 5G. So these are some of the things na nakita ko online. So if you want to check sa GSM Arena, again, this is not a paid advertisement of these brands, no? Connect ko lang yung mga available na devices talaga on GSM Arena. Yan. Ano po yung ibig sabihin ng SA at saka NSA? Later na pag-usapan natin yan. It's a good question. For now, let's just absorb it first na kailangan nating makita yung sa 5G ay meron siyang nakalagay. 5G bands, SA, NSA, and SA. Mamaya balikan ulit natin to if you want, no? 5G bands, meron siyang nakalagay na numbers, meron siyang SA sub 6 millimetric wave, wave. Meron tayong 5G bands, SA sub 6, and so on and so forth. Okay? May mga numbers, may mga letters din. Okay? Kaya yung mathematics, sabi nila complex kasi meron na siyang letters, meron siyang numbers, meron pa siyang letters. Meron siyang XY, meron pa siyang Z, di ba? Tapos meron pa siyang E, yung Euler number. Anyway, no? Ngayon, tandaan natin to. Tignan lang natin yung devices. If you want to check if your phone is capable of 5G, then you have to check these specifications before purchasing. Lalo na kung bibili ka sa ibang bansa. Okay? Kasi different bands, different technology, or different country, different bands. Okay, so curious lang ako kasi kanina nakaka-check ko lang din ay Apple iPhone, I think this should be announced this November. So meron na din pala siyang 5G, SA, NSA, sub 6, pero again wala siyang specific numbers kagaya ng mga to, no? 54166, no? Sub 6 pa lang nakalagay. So I think they have to put those specification. Correct, sir. gsmarina.com po yan. Okay, so higher throughput, no? Bakit pa tayo nagkakaroon ng higher throughput as benefit of 5G? Again, di ba meron tayong link between the tank and your glass? Okay, if you try to imagine it again, no? If I will stretch the pipe to a bigger pipe, no? What will happen? Ito naman, another question, no? Ay, meron na palang sagot pala. Okay, so how much water can you consume in a year? So if this pipe capacity, yung sa left side natin, has 100 ml per second, in a year, if you try to calculate it, multiply by 60 seconds, multiply by 60 minutes, multiply by 24 hours, multiply by 30 days, multiply by 12, no, you will be able to, or you will arrive at this number. 315 millions of what a liter, millions of water, no, in a year. Now, if you have this bigger pipe of ml per second, ilan naman ang consume a year? You will be able to consume 31 million liter of water per year. Okay? Clear? Clear ba yan? So, sasabi lang natin dito, if you are planting a bigger field, no, meron kang mas malaking pipe at ikaw ay isang farmer, no? Let's support our local farmers and local agriculture. Mas madami kang madidiligan na lupa as compared dun sa kabila. So ibig sabihin in a year mas magiging efficient ka because at the same time the left side is watering his agricultural land, no? As compared to the right side, ibig sabihin mas madami talaga siyang madidiligan na puno or let's say mga tanim niya. Okay? Okay? So, now, kung titignan natin, mas madami kang ma-produce na goods, mas madami kang ma-produce na goods that would be able to serve yung people around you or let's say yung support yung business mo. So, that's how we see it. As compared dun sa kabila, na mas konti yung nadiligan niya, mas konti yung magiging produce niya. Again, factoring out lahat ng mga mga acts of God, no? Let's say kung babagyo yan, syempre typhoon, iba pa yun. Ang sasabi lang natin, assuming na condition is very good, tama yung panahon and wala tayong climate change, no? Yan ang magiging resulta niya. Trying to analyze this one. So now, kaya tayo nagkakaroon ng higher throughput because of this bandwidth. Alam naman natin, no, Shannon-Hartley formula, that the capacity is somehow related to the bandwidth. The bigger the bandwidth, the bigger the capacity there is, no? Yes, sir, pwede po kayo makakuha ng certificate as long as you wait and para ma-complete yung 90% of the time. Okay? Now, if you try to analyze it again, no? Sa LTE has a limited, it has set as well specification, no? I would not say limit, but they set the standard to 20 megahertz of bandwidth. But 5G has a different then. So makikita lang natin dito, just a simple comparison. If we keep the bits at the same time, we keep the same modulation, ibig natin sabihin, same bits na pinapadala at this certain space. Okay? Trying to analyze this one, mas madami akong mapapasok na bits doon sa mas malaking pipe as compared to the smaller pipe. So meaning kung titingnan lang natin dito, no, I can have 35 beats after 5 seconds. Okay? Same thing din dito. I will have 10 beats per 5 seconds. So meaning, ang sasabi natin dito, ang rate ko per second, again, kasi ito yung something na naintindihan natin. So, 2 beats per second to, ito, magiging 2, 4, 7. 7 beats per second. Okay? So, from that, just putting up yung number of beats that you could or put it in that bandwidth, yan yung magiging resulta niya. Mas malaki ang pwedeng ilagay na 5G. Kaya tayo nagkakaroon ng higher throughput because there are higher number of beats. Parang kagaya lang nito. Because, no, alam naman natin, the wider the bandwidth, the higher number of beats are transferred over a period of time. Okay, basic na lang, representation lang ng bandwidth, no? If you try to look at the frequency na axis, kita natin that the bandwidth is equivalent to F2 minus F1. So yun yung kapal niya. So makikita natin yung comparison between FC1 and FCN that the bigger bandwidth goes to FC1 as compared to FCN kasi mas maliit yung kanyang bandwidth. And again, yung frequency natin is being governed by NTC. So ina-allow niya tayo to operate at certain frequencies din, at certain bandwidth din. Okay. And using or overspanning your use of bandwidth, no, pwede yan mag-cause ng interference with other frequencies. Okay? Clear pa naman? Okay pa naman? Okay. Now, if you try to look at, again, itong part na to, nasa, ayun, clear po, clear. Okay, thank you. So, frequency, ano ito, x-axis niya. Ito, ang ano naman is time. No? Sasabi lang natin dito, why different carriers won't affect each other because they operate at different frequency. Okay? So, halimbawa ito si F1, Fn-1, Fn. So, iba't iba silang frequency. And alam naman natin that yung frequency natin somehow related to time. Kasi, pagka binilisan mo or tinaasan mo yung frequency, again, frequency is measured in hertz. Kahit single yan or one yan, hertz pa din ang tawag natin because it's named after hertz, no? It's a surname. At alam naman natin that 1 hertz is equivalent to cycles per second. So, kung 1 hertz yan, ibig sabihin 1 cycle per 1 second yan or per second. So, if you have 2 hertz, 2 cycles per second. Kaya lumalabas yung mga ganyan. So, this one has a higher frequency because it can be around, let's say, 1 to 2.5, no? 2.5 kilohertz or 2.5 hertz per, 2.5 cycle per second or 2.5 hertz. This one is straightly 2, no? And so on. Ito naman, versus time naman yan. Ito versus frequency. Okay? Multiple frequency yan sa iba't iba. Then we have sinusoidal. Pagka time naman natitignan natin, the wave behaves like this one in relation to time. Okay. Now, that's why we have higher throughput gawa nitong standard na to. Okay? Again, you can check the references in 3GPP dun sa mga values na available. Pero sasabi lang natin dito is that for LTE, the maximum na pwede niyang gamitin na bandwidth ay 20 MHz. Ito yon. Pwede ka din gumamit ng lower bandwidth like 15, 10 MHz, 5. Depende kung ano binigay sa'yo ni NTC or depende kung ano yung binili mo na or license ka to operate. Okay? Kung license ka to operate, let's say kung binigyan ka lang ng 5 megahertz, then you would not be able to operate at 20 megahertz kasi bawal yon. You will interfere with yung neighboring mo na frequency. Okay? Kaya kung 5 megahertz lang, hanggang 5 megahertz ka lang. Kung naman binigyan ka ng 20 megahertz, then you can operate at 20 megahertz. So now, paano po kung meron akong, let's say, 100 megahertz of spectrum? Then you can do multiple carriers na tig to 20 megahertz. So that can be 5 20 megahertz para magamit mo yung buong spectrum mo na wala kang sinasayang. Okay? So now, with 5G, the maximum that you could get is 800 megahertz of bandwidth. Imagine that. Though itong 800 na to, wala pa siya sa release 16. No? I think paparating pa lang yan. So part siya ng FR2. FR2 is frequency range 2 na makikita natin yan later. Okay? So for the frequency range 1, malalaman din natin yan later kasi nakatag naman dito sub 6 GHz, no? FR1, and then we have the FR2, 5th generation din yan, na millimetric wave naman ng gamit. Discuss natin in the next slides. Makikita natin dito, if you are using FR1, the maximum that you could get is 100 MHz. So again, paano po sir kung binigyan ako ni NTC ng non-contiguous, meaning binigyan ka ng dalawang tig 50 na non-contiguous, meaning hindi mo sila pwedeng, or nang pagsabi natin non-contiguous, hindi sila tuloy-tuloy, no? 50, running from 1950 to 2000, no? Tapos meron kang 2010, kasi may gumagamit na radio operator sa 10 MHz in between. So ito tinatawag nating non-contiguous. So sasabi lang natin, pwede pala mag-annotate dito, no? Or give my drawing. So halimbawa binigyan ka ng non-contiguous, no? Halimbawa ito yung let's say first frequency mo na 50 MHz yan, let's say, no? 50 yan. Okay. 50. Tapos meron kang isa pang 50, no? Dito. So ngayon, ang question, ano ba yung maximum na pwede kong i-operate? Pwede ka mag-operate ng dalawang 50 kasi dito halimbawa may gumagamit na radio operator na 10 MHz. Okay? Let's assume. So, dalawang 50 MHz yan. Hindi mo pwedeng gamitin yung 100 kasi, di ba? One is wala kang instantaneous bandwidth to operate ng, let's say, 110 kasi ang FR1 can operate at 100 MHz lang. Hindi ka pwedeng gumamit ng 110 kasi that's outside the range of FR. Ngayon, kung pasok yan sa FR2, then pwede kasi pwede kang 800, no? But then again, may mga specifications tayo na tinatawag na pwede ka lang mag-operate at certain bandwidth. Now, dalawang 50 ang gagamitin mo dito. So ngayon, pag halimbawa, ni-negotiate mo, sir, pwede po bang these are ideal situation, again, so halimbawa, sir, pwede bang iusog ko ng 10 MHz yung sa akin, bigyan na lang yung sa dulo sa ibang operator. So kung meron kang 100 MHz of bandwidth dito, pwede mong gamitin yan na maximum na 100 MHz of bandwidth. Okay? Yan. At pagka ginamit mo yan, no, pwede ka masilip na NTC, pwede ka niyang i-penalize based dun sa paggamit mo ng unlicensed na bandwidth or spectrums na ginamit mo. Okay. So for 5G sub-6, no, 100 MHz, meaning, tingnan na lang natin, no, just merely comparing it to LTE, kung halimbawa you're operating at 20 MHz versus mo dito, that could mean 5 times bigger than your existing LTE. Okay? Kaya tayo nagkaroon ng higher throughput. It's because of this bandwidth specification coming from the specification, from the release. In terms of spectral efficiency, mas efficient po ba yung non-contiguous bands compared to contiguous? Spectral efficiency mas better si contiguous kasi if you try to analyze it, no, kasi the whole is better than the sum of its part. Yun lang yung yun yung pwede natin gamitin reference doon. Okay. But when we say spectral efficiency kasi it's the number of bits that you can transfer per second per hertz. Tama? So, kung contiguous yan, in terms of, well, depende sa gamit pala, no? Pwede nating i-check yan, no? Depende kasi sa gamit. Kung heavy user ka, no? It's better to use a bigger bandwidth. Pero kung halimbawa, kung small short of data lang naman, no? Then you can go to the 50 or to the smaller bandwidth. It's not a straight to the point answer. May may mga pasikot-sikot pa or may mga conditions. Okay. We move on to the FR na ito. Okay. Ito siya. Yan. So frequency ranges, FR1. Pag sabi natin FR, it will just mean frequency range. So meron tayong frequency range for 1 and meron tayong tinatawag na frequency range 2 for 5G na NR. NR would mean new radio or 5G. Mamaya nasagutin natin yung SA at NSA. Now, for frequency range designation, FR1, ito yung frequency range niya. 410 to 7125 megahertz. Okay? Ito yung nakalagay sa ating standard. Kaya, sasabi ko sa inyo, pagka chinek natin yung phone natin, balikan lang natin ha, quick. Here, specify natin dito itong, hanap tayo ng ito, si Huawei Enjoy 20 Plus, ano ba ang pangalan na Enjoy? Okay, it's not this, again, this is not a paid advertisement ha, wala itong kanalaman po. ginagamit lang natin yung information from the 5G band. Meron siyang 1, 3, 38, 41, 7, 77, 79, SA and SA. So let's check first yung mga numbers. Natandaan nyo pa ba yung mga numbers? Yan. Pag pumasok yan dyan, ibig sabihin your phone is capable of connecting to this type of frequency kung yan ang gagamitin ng operator. Okay? Let's say, gagamitin ni brand X, si let's say 41. Okay? Sabihin natin si N41, dapat si N41 is capable din or dapat nandun din siya sa specification ng device mo. Kasi kung gumamit ka ng N1, no, at wala siya dun sa specification, then you won't be able to connect. Sa frequency pa lang, filtered out ka na. Okay? Question, can you do carrier aggregation with 5G? Si Sir Engineer Sajid, advanced po yan, pero the answer is yes, but it's still yet to be finalized in the next releases. Okay. Yan, dapat yung numbers natin, pasok dapat yan dun sa ating specification. Okay, so makikita natin, meron tayong natawag na duplex mode. Okay, pasadaan lang natin ito mabilisan. FDD, TDD, tinatawag silang duplexing mode, meaning yung downlink mo at uplink are separated by this type of duplexing. Meron siyang pwedeng tinatawag na frequency. Pag frequency division duplexing, paired spectrum, meron kang one for uplink, meron kang meron kang isa for uplink. So meron kang paired spectrum. At saka magagamit mo siya buong all the time or all the time mo siyang pwedeng gamitin. Si TDD naman, wala siyang kapares and that's sad. Okay, malungkot ba? Okay, wala siyang kapares tapos meron pa siyang time division. So meron lang time for uplink, meron pang time para sa kanya, para sa downlink, uplink. Okay. Clear? So ngayon meron kayong makikita dito na SUL. These are new to duplex mode, no? SDL tsaka SUL, yung ibig sabihin niyan is supplementary downlink and supplementary uplink. We'll try to discuss that in the challenges, no? Pero ibig sabihin niyan, supplementary downlink and supplementary uplink. From the word itself, supplementary, it supplements yung ating base technology which is your FDD or TDD. Okay? Kaya wala siyang tinatawag na duplex mode na TDD or FDD. So now, meron din tayong tinatawag na FR2. FR2, yung mga frequency na gagamitin niya. Okay? Though may mga ibang usapan, no? I'm not yet sure on when they will release it. They will use higher frequency than this stated. Hindi pa natin din alam whether they're gonna put it in the FR2 or they will add the FR3. So that are yet to be discovered and explored in the next releases, no. So makita natin dito naman from 24 250 to 52 600. And these are, kung titignan natin, no, ang difference nila between the two, these are more on megahertz. Kung titignan natin, no, 4 digits megahertz ito, 5 digit na megahertz, meaning they operate at higher or higher than 6 gigahertz. So makikita natin kasi dito, no, or 7 gigahertz, no. 7 gig, this one are operating 28 gig, 40 gig, no, and 37 gig as well. Kagandahan lang kasi nitong paggamit ng FR2 is that, tignan mo yung ranges niya, 26,500 to 29,500. Ibig sabihin, you have almost 3 gigahertz of capacity. Imagine that. Kaya dun sa FR2 natin na bandwidth, no, you can go as much as at 800 kasi capable yung ating frequency ranges. And dito naman, alam naman natin na, well, kung titignan natin, no, in a class setup, let's say kung meron kang 3 operators in the country, if you will allow this, let's say N77, N33 to 42, ilan yan? Almost, 900 megahertz of bandwidth at iba't ibang operator pa, meron pang mga local radio operator, and so, kaya makikita natin dito na mas mababa yung ating bandwidth, hanggang 100 lang. Okay? So, clear pa naman? When we talk about frequency, ano po yung difference ng FDD po? Nasagot ko na ba siya? Tama, no? So, FDD, again, gumagamit siya ng frequency division. Yung downlink mo at uplink mo are separated by 2 different frequency and they can be used at the same time. Okay, imagine yung parang voice phone natin, yung voice call natin, pwede tayo mag-usap using our cellular phone or mobile phone ng diretso na walang putol because your uplink is separated by your downlink. or yung sinasabi mo at saka yung narinig mo are operating at different frequency. But for TDD, imagine yung parang ano to, mga walkie-talkie. Kung downlink yung isa, downlink lang. Kung uplink yung isa, uplink lang. Hindi kayo pwedeng magsabay. Okay? But in terms of this cellular technology, these are being processed at a millisecond time. So hindi natin sila napapansin na nag-change sila yung uplink and downlink. Kung sa user end natin, these are seamless. Hindi natin sila naramdaman. May assign po ba na telco in the FR2 bands? We have to ask NTC na meron tayong NTC guy here. Sila kasi sila NTC yung makasagot niyan. Okay. So sa ngayon, natin masagot. Now, kung titingnan natin, yung spectrum range natin, nasan ba si FR1 tsaka si FR2? Nandito sila. In terms of wavelength, makikita natin na mas maliit ang wavelength pagka tumataas siya from the microwave, no? At saka yung frequency niya tumataas. Okay? So makikita lang din natin dyan na habang tumataas yung ating frequency, that's a basic, no? Because your wavelength is inversely proportional with your frequency. Okay, so dyan nakalagay yan, sila 1, FR1, tsaka sila FR2, dyan sila nakakluster. So ngayon, kung tinatanong nila, hindi po ba masama sa kalusugan ang 5G? That's the first thing we have to understand. Saan ba sila nag-operate? Sa part ng spectrum? So natin makikita? Dito, di ba? Yung spectrum natin for 5G nandito at saka nandito. At makikita natin na yung ultraviolet rays, nandito sila. Ano ba yung ultraviolet? Yung ABN na ultraviolet, these are coming from the sun. So mas, if you stay too much, no, sa labas ng bahay mo nang wala kang sunblock, then there might be chances, no, na makakuha na sabi, magkaka-skin cancer ka, no. Okay, may non-ionizing ang RF po. Yan, very good. Si Engineer Michael, no, non-ionizing, correct. Yan, nakalagay sa ating specific siya. Non-ionizing ang ating mga cellular frequency hanggang microwave. Ang mga ionizing natin starting from ultraviolet, ito yung coming from the sun, no? If you're exposed too much. And yung X-ray. Kaya yung X-ray you're allowed to have it in once a year lang kasi nga yung effect niya sa ating katawan. Okay? So visible light dito naman, no, once the light strike an object, so nakikita natin yung kanyang kulay. Okay. We can assume po that we are same in health concerns. Okay, good. So tama tayo, no? We are safe. Okay, safe. Safe po tayo sa 5G pero sa pandemic hindi pa po. Thanks for that information, sir, and to all other engineers. So now, after the frequency, no, we have the bandwidth, the frequency, the capacity. Now we move on to the other key technologies. We have the coding, modulation, at saka MIMO. So familiar ba kayo? Kung hindi kayo, let's try to run through. Tingnan natin. Let's try to demystify, sabi nga ng title ng ating presentation. No? So now for higher throughput, no, makikita natin that we need to protect yung data that's coming or passing through whatever channel. Be it wired, be it fiber, no, coax, and even wireless. At alam naman natin that the main problem, the main interference is not coming from either the device or either the transceiver or transmitter. It happens every time in the medium. Okay? So nasa medium siya lagi. Kaya we have to protect. Kaya may tinatawag na coding. At least the coding would help us to protect yung data na napasok natin. So if we try to look at this one, kung meron kang encoder, yung data mo is 1. So pag pinasok mo sa encoder, lumabas yan, meron kang 1-1 kasi gagawin niyang redundant yung information mo. Tama? So ibig sabihin pagka error yung nakuha mong information sa una, meron ka pa rin redundancy. Sasabihin niya, ito yung information na kagayang-kagaya nung unang pinadala mo. So that would mean na protected ka kasi meron kang same information na nakuha. Hindi nawala yung data. Now, syempre, paano kung mag-error din yung aking redundancy? That's why I have to add another. And so on and so forth. Makikita natin dyan, no? Habang tumataas yung protection rate mo, habang tumataas yung protection mo, bumaba yung rate mo. Kasi ang rate natin can be calculated through the number of input over the number of output. So in this case, 25% ang ating rate, meaning pagka kinalculate mo yung buong throughput, let's say if you have 1 millions of bits na pinapadala ng transceiver side mo and then you encode it, then the number of data na ipapadala mo over the air ay magiging times additional trim. So magiging 4 lahat, 4 Mbps of data from the 1 millions of bits na papadala mo. Okay? So ganun yung nangyayari. So yung rate natin bumaba siya, or let's say kung babalik rin naman natin, kung kailangan magpadala ng kung ang sagad ng channel mo ay 1 Mbps or 1 millions of bits per data, ang pwede mo lang ipadala during that time is 25 bits lang talaga as original data, because the rest of the 75% are purely for redundancy. So magiging siyang inefficient. Kaya hindi natin or hindi natin ginagamit yung ganitong klase ng coding because of the rate. Kasi babagal nga naman ang ganda ng effort mo on the bandwidth, ang ganda ng effort mo sa ibang system, tapos bigla mong lalagyan ng ganitong klase ng coding rate, then ang mangyayari, ibababa yung rate mo. Pero again, protection wise naman, ang galing. So now, we have to think, or we have to design a technology that would both serve yung protection mo at the same time yung rate mo. Okay? So meron kang encoder. Okay? Yan natin to, Kung meron kang, let's say, meron kang data na 111, in-encode mo siya, then you have to repeat it automatic. 50% agad ang yung rate, tama? Kasi 3/6 is 50%. So pagdating pinadala mo over the air, pasok dito sa sa decoder mo, let's say yung modem mo or yung phone mo, yung device mo. Pagdating sa decoder side, nakopya, tamang kopya niya yung redundancy. Okay? Meaning yung information mo, nakopya siya ng redundancy. So ngayon, makikita ngayon ng decoder na 010 pero may redundancy ka na 111 ang sabi. So ma-define ko na itong first bit at saka third bit are both 1 dapat. So i-correct ko siya and then ma-recover ko yung data. O di-check ka ngayon. Paano kung yung redundancy mismo nagkaroon ng problema over the air? So 011 na, 010 na, tapos pagpasok sa decoder, ganun din, pareho sila. So matitreat niya to na 010. Kasi yung redundancy mo is 010 din. Diba? So ngayon, sasabihin niya, ito yung output mo, 010. Diyan tayo, may problema. Diba? Halimbawa, sinabi mo, I miss you. Tapos, ang dumaan pala sa kanya ay I love you, patay ka dyan. Diba? Kasi lalo, hindi ka pa man nanliligaw, gano'n yung sasabihin mo. Sabihin ni Kevin Hart, wait, what? So ngayon, kailangan tayong mag-isip ng ibang way pa. Para at least maka-produce tayo ng same. Again, ang objective natin is to have a very good protection. At the same time, yung rate natin ay mataas pa din. Okay? So ngayon, nakaisip sila ng ibang paraan. So ang gagawin natin is you have to put a parity. A parity checker is the one that checks yung remaining information mo. Yun yung gagamitin kong redundancy. Masasabi lang dito is that pagka meron akong 3 daw, sabi niya, pinasok ko sa encoder, pag lumabas na 1 yung information, ibig sabihin niya lahat yan 1. Tama? So masasabi niya na, okay, padala ko ng information. Pag lumabas yan, pag nakita mo yung parity checker na 1, automatic lahat ng information mo, ipadala mo yan o hindi. O mayroon problema yun over the air, alam ko na 111 yan. So pagdating na dito, okay, good. Nakita ko agad na si number 2 ay hindi siya part ng information or part ng information but it has an error. Kaya ang gagawin niya ay i-correct niya. Dahil nga parity 1, okay, yung pang second bit ay 1. So 3 ones daw sabi nitong 1. Okay, di ba? Okay naman yon. Kasi somehow na-prove natin na working siya, So ngayon pag 0 yan, malamang or pwede kang maglagay ng another. It depends on the system kung ano yung i-assign niya number to have this digital information. Kasi alam naman natin in digital information, you just have to turn it on, turn it off. Alam natin kung ano yung magiging labas ng information. Okay. So, now, paano naman kung mas madami pa lang information? Halimbawa naman kung ang system ko ay 5G. So, mas madaming bits ang pwede kong ipadala over the air. So, ngayon, kung i-check ko lahat ng yan, sabi niya, okay, 1. Ang sabi niya, sa parity checker ko, okay, alam ko na 10111 information ko and I would assign that one as 1. Ngayon, pagdating sa over the air, patagos yan sa over the air. Pasok yan dito. Ang na-recover na information ay 1100111. Patay na kasi ang alam mo, meron ka lang 1, 0. Dalawa yung 0 mo. Alin ngayon dito ang gagawin mo? 1. Kasi kung i-turn on mo ito, iba na yung information dito. Di ba? Instead na mahal kita, baka mahal ko siya na ang may padala mong information. No? Same thing dito. Pag pumunta dito, baka iba din ang information na may padala. That's why, ito yung problema ng mga ganitong klase ng system. Kasi, lalo na pag madamihan ng information, hindi sila magiging efficient. Diba? Kasi hindi mo na alam. Kumbaga, pagka pinrocess mo yan, maghahang lang siya maghahang lang or rotating or processing kasi hindi niya alam ang gagawin niya. Dead end na siya in terms of processing. No? Okay. So, deads na. Now, ano ba ang best way to do it? So, kaya nakapag-create tayo ng tinatawag na LDPC or tinatawag na low density parity check is to have like this one. So, instead of having clustering them, kaya tinatawag na siyang low density kasi konting density ng information, ikakat mo sila across all the whole data, tapos lalagyan mo sila ng parity checker each. Okay? So, parang kung titingnan mo yan, no, multiple unknowns, multiple equation. Pero if you try to analyze this one, kung i-break down mo sila into clustering them into smaller density, so makakakuha ka ng 3 equations, 3 unknown, 4 equations, 4 unknown, 5 equations, 5 unknown, and then pagka break down mo yan, 5 equations to 5 unknowns, solve it, meron ka ng 4 equations, 4 unknown, kasi nakakuha ka ng isang information from the 5 equations, 5 unknown. Going down to 4 equations, going to 3 equations, 2 equations, and then it will lead to 1 equation. And then madidetermine mo kung aling bits ang kailangan i-correct because of disparity. But the problem with this one, again, is paano ulit kung yung redundancy mismo or itong parity checker mo ang merong problema. So the only way to solve this one is to have a parity check then between the redundancy. Okay? So ginagawa natin, even the redundancy has their own parity checking. So that, ang mangyayari is that mag-parity check ka dito on the series of data and then you have a parity check as well on the redundancy. In that way, both protected yung redundancy mo at saka yung information mo. And then based on their analysis, no, ginawa nila ito, ang pag-cluster is purely random. So wala tayong, hindi ganito yan. Pwedeng itong tatlong yan, pwedeng ito isang cluster yan, very random. Kasi mas tingnan nila, mas efficient gawin pagka-random as compared to structured na ganito. And they run this one through simulation, no? Hindi to mano-mano. They have to run it into computer simulation. In that case, no, kung makikita natin, may question pa? Walang question, no? Meron ba? Okay. Wala naman, no? So makikita natin dito na just a simple calculation. Again, these are numbers, no? Just for representation. Makikita natin information bit mo is 50. Redundancy mo is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the code word is 60. Okay? So makikita natin na meron tayong rate of 83%. Okay? So, code word meaning ito yung pinagsamang information tsaka redundancy. Okay, so that's your output. And then your information bit is 50. So, 50 over 60 is 83%. So, as compared din sa 50%, this can be as efficient, no, in terms of coding. Okay, so protection, achieve, rate, achieve. So, tinatawag tong low density parity check and this one is not a new, hindi to bagong technology. Matagal na technology na to. Ginamit lang nila for higher throughput or higher bits of transferring higher bits over channel or through channel. Clear ba? Clear nakuha ba natin? Kaya magpapadala tayo ng 1-0. Pa-like ako kapag may question or pa-like ako kung if you understand it or kung clear to. Checking? Check mo yung redundancy, check mo yung information. Then good. Clear po. Okay, thank you. Now, ito yung LDPC, no? Or ngayon, tingnan natin ngayon yung tinatawag nating modulation. Okay, yung tinatawag nating coding yung kanina, ito tatawagin natin siyang modulation. Alam naman natin that every digital communication, lahat, as in lahat, no? Hindi mostly, hindi 99%, hindi 99.99, no? Na kiniklaim ng iba dyan, 100% ng digital communication is run by 1 and 0. Naniwala ba kayo doon? Na lahat niyan, 1010 lang yan. Kaya kung ang tanong ay yung po bang COVID ay napapadala through 5G signal? The answer is no, directly, no. If you're talking about the COVID as a pandemic or as a virus, this cannot transfer or this cannot pass through sa mga antenna, sa mga electromagnetic waves, no? And even power. But if the COVID-19 na word, i-convert mo yan into ASCII code, i-convert mo yan into digital 10100011, padaanan mo yan sa channel, then tatagos yan. The word, o baka nga lang yan, mga 2 KB, 5 KB na information, padaanan mo yan sa channel, chat, dadaan yan. Okay? Pero hindi as a virus, but as an information. Okay? Kaya hindi po totoo yun. Nasasabi lang na ang 5G ay carrier ng COVID sa bansa. That's not true. And even to other known countries. Okay. Sir, ano nga po ulit ang workings ng OF? Sir, ano nga po ulit ang workings ng OFDM po? Yan, pag-usapan natin yan, no, later. Higher throughput, no? Number one, it's because of the modulation. Okay? The modulation, at alam naman natin, dahil nga base 2 nga yan, so nakalagay tayo ng base 2. Pag 2 raised to 1, so ibig sabihin, dalawang possible combination, that is 0 at saka 1. Tama? Kasi first bit at saka second bit, or first bit 0, the second bit is 1. So now, if you have a 2 raised to 2 or 2 raised to 4, no? Meron kang 4 possible combinations. Gets pa naman, no? Itong pulang po, yung kung saan siya naka-raise, yan tinatawag nating bits. So, ibig sabihin, yun yung pwede mong ilagay na laman during the transfer or modulation. Okay? Kasi sabi natin dito, okay, listen closely to this one, kung ano yung nakalagay sa taas dito, no? Siya yung number of bits na pwede mong ipadala per symbol as per quadrature amplitude modulation. Okay? Ano ba yung quadrature amplitude modulation? Ganito yan. So, halimbawa, no, 2 raised to 6. That's equivalent to 64. So, pag sinabi natin 64 QAM, that is a base 2 or 10, that is raised to 6. So, ang bit composition niya would be 0000 as 1 and the 64th bit is 1111. Okay? Now, one symbol, ang tawag natin sa mga ganito, di ba, ay symbol? So, pagka ni-represent natin siya into a constellation, we'd be able to understand na ang isang bit or ang isang symbol ay mag-carry siya ng 6 bits. Okay? I have to repeat that. Ang isang symbol ay mag-carry siya ng 6 bits. Yan ang ruling ng modulation. So now, ano bang kinalaman ng symbol na yan? At saka anong kinalaman ng number of bits na yan? Sa information or sa aking buong system. Okay? Kasi sa resource elements, ito, baka magulat kayo, no? This one is a LTE frame structure and it's same with 5G din. No? Makikita natin dito, one resource element is equivalent to a subcarrier and a symbol. Okay, ulitin natin yan. Gusto kong i-highlight ito kasi kadalasan madami nalilito dito. Isang resource element daw, isang resource, meaning pagka nag-download ka, you will be needing bits, di ba? Kukuha ka ng bits from a server. Kukuha ka ng bits from let's say, Netflix, no? Mainit yung Netflix ngayon kay MTRCB, no? Okay, ibang topic yan. Okay. Yung Netflix, kukuha daw ng information. Let's say, kukuha ng manonood ka ng HD. Kailangan mo ng resource para mapadala yung information na yon from the server going to your device. Now, makikita natin dito, one resource element, meron siyang katumbas na subcarrier at saka meron siyang tinatawag na 1 slot 7 symbols. Isang ganyan, meron siyang symbol. Ibig sabihin, yung symbol na sinasabi ng modulation, yun ang pwede kong ilagay na laman dyan. Or ito yung maximum capacity ng para mag-transfer ng bits over the air. Clear ba yun? Okay. Last slide. Ulitin ko ulit. Isang symbol, maglalagay yan ng 6 bits. Kaya niya maglagay ng 6 bits kung ang modulation mo, clear ko din yun, kung ang modulation mo ay 64 QAM. Okay. 64 QAM, 2 raised to 6, 6 bits per symbol. Ibig sabihin, ito yung mga possible na pwede kong ilagay. Pwede during the time, halimbawa, assuming lang, no, ito, quick na ito, para lang maintindihan natin. Okay. Kung magpapadala ka ng information na 11111, okay, I can just easily pull up this symbol. Lalagay ko siya dun sa resource element ko. And that would be your data already. Okay? So, kung titignan natin, isang block daw, pwede siyang, or isang symbol daw, pwede siyang maglagay ng 6 na bits. So, just a purely calculation, no? Again, wala tayong sasabing efficiency dito, wala tayong sasabing channel capacity or whatsoever, no? Sasabi lang natin dito is modulation. Kung modulation lang, no? Modulation natin, 6 bits daw, tama? 6 bits using a 64 QAM, 6 bits per symbol. Multiply natin, alam naman natin that this stretch or this slot, no, meron siyang 7 symbols. Okay? 7 symbols nga naman yan, no? I-divide ko lang siya ng 0.5 milliseconds. Bakit? Kasi itong one slot na to is 0.5 millisecond sa frame structure ng LTE. So ito. This one. So pag titingnan natin, no, one slot is 0.5 millisecond. Pag in-expand natin, meron tayong 7 symbols using cyclic prefix, no, short prefix 7. Kasi pagka nagano ka, pag nag-extended ka, that would be 6 lang. Pero just for the purpose of discussion, pag naka-normal ka, no, 7 symbols yan. 7 symbols, 6 bits per symbol, divide mo ng 0.5 millisecond, meron ka ng rate agad. Tama? You get my point? Meaning, if you modulate at 64 QAM, ang pwede kong ipadala na bit at 0.5 millisecond in one subcarrier of information, isang block yan, isang 1, 2, 3, 4, 5, 6, 7. 7 lang talaga, no? Ito lang taas na to. Focus tayo dito. Okay po. Ayan. Makakuha na ako ng 84 bits daw per second. Kasi multiply ko lang, no? Bits, symbol, cancel, symbols, bits per millisecond. I-convert ko lang into second, magiging siyang 84 kilobits per second. So nagkaroon na ako ng tinatawag na rate. Diba? Kasi ni-respect natin yung data transfer in reference to time. Okay? Kaya magkano, saan ang galing yun? Saan ang galing yung Mbps, kbps, bps, dps na yan? Diba? So modulation has an impact on your data transfer speed. Okay? So makikita natin, dahil nga 1 PRB yan, we can just have multiply it to 12, no? Itong 1, 2, kasi this one is 1 PRB. Okay. 1 PRB. Ang bihira, no? This LTE frame structure, or medyo technical to, no, at least for some, pero titingnan natin, no, it's somehow helpful. Alam natin, maintindihan natin yung basic principle on how we transfer yung information. So yan, no, itong buong to is 1 PRB. So meron siyang 12 subcarrier kung tawagin, kasi sige na, i-calculate natin. Okay, meron tayong tinatawag na 20 MHz bandwidth, no, for LTE. Okay. Pwede ba mag-annotate dito? Pero sige, daan natin mamaya para lang matapos natin muna to. Okay. So, meron tayong 5 milliseconds. So, makikita natin 1 PRB rate multiply ko lang ng 12, meaning kung itong buong to ang gagamitin ko, meron na akong 1 Mbps. So, meaning 1 PRB or physical resource block kung tawagin, no? Physical resource block is an equivalent of or is equivalent to multiplying the number of symbols at saka yung number of subcarriers in one slot. Okay, so that would be equivalent to 1 Mbps. So imagine, no, kung meron kang 1 PRB, that is 12 times 84 kbps, yung kinalculate natin kanina. Okay, so meron akong 1 Mbps. So now, if you multiply that one into the 100 PRB based on the LTE standard, because of the 20 MHz bandwidth, meron kang 100 PRB. So kung 100 PRB yan, no, makikita natin that you can have 100 Mbps if you are using, again, if you are using a 64 QAM or 64 quadrature amplitude modulation. Okay? So imagine sa 5G. Di ba? So kung meron kang PRB na times 12, no, may pag-usapan natin to, pero because of the bandwidth, no, and yung efficiency niya, and even 5G kasi can use even higher modulation. Ito. So, yung specification number 36.783 sa Evolve Universal, no, introduction of quadrature amplitude modulation, LTE pa lang to, and I think they will adopt this one as 5G as well. Imagine na lang kung ito yung gagamitin. 2 raised to 10, that is 1024 QAM. Okay, 1024 QAM. So, imagine 2 raised to 10, ilang symbols yun ang pwede mong ipadala, no? Multiply mo lang, then you will have that type of throughput. Okay? Clear ba? Clear? So kung clear naman, no? Let's move on to this, what we call the OFDMA. So wait lang, may nag-chat. Clear po, sir. Okay, good. No? Pag sabi natin FOFDMA, no? Ang first question niya kanina, isa na ba yung OFDM? OFDM is just separating your users. Again, this has nothing to do with TDD. This has nothing to do with FDD. Because FDD and TDD, ano sineseparate niya? The signal. It's not the user, it's the signal. Uplink, downlink ng user, they're being separated. Now, to make it more complex, no, to make it more complex, tapos demystifying yung title, no? Ano ba naman ni? Okay. So, makikita natin, no? Ito, we're separating naman yung user. Okay? We're separating the user kung yung access nila papunta sa network or papunta dun sa channel na yon. So, kung titingnan natin, OFDM is just looking at the time. Okay? Again, baka malito kayo, TDD has nothing to do, or time division duplexing and frequency division duplexing has nothing to do with dividing or having or giving access to users with respect to time. Okay? That's another thing. OFDM is separating mismo yung users mo na mag-access. So meaning, halimbawa lang, parang ano yan, parang let's say kung pipila ka sa sa mga tindahan, di ba? Di ba meron kang queuing, so meron kang number, so hinahati mo yung users mo with respect to time. So halimbawa, number 1 from 1 millisecond to 5 millisecond, or again, dahil nga natin maintindihan yung millisecond, pwedeng from second 1 to second 10. Diba? Tapos meron kang 11th second to 20th second si user 2 and so on and so forth. Yun tinatawag nating OFDM. But pagdating sa OFDMA, which is a basic, or this is the new technology that's introduced in LTE, OFDMA is orthogonal. Pag sinabi nating orthogonal, diba? Pag sinabi nating clear, okay. Thank you, sirs. Okay, pag sinabi nating orthogonal, okay, orthogonal meaning they are separated by 90 degrees. At alam naman natin that frequencies can be separated by phase as well. Ito yung natawag nating phase, and phase is 90 degrees. Alam natin, di ba? Pag gumawa tayo ng constellation, meron yan, tatawag na phase, 90 degrees separated. So pag tinignan mo yan, with reference to time, so meron akong frequency 1, okay, with respect to time, ibig sabihin, saan yung 90 degrees ko? If this one, ang buong cycle natin is 360 degrees, no, pwede kang mag-cut dito, pwede kang mag-cut dito, pwede kang mag-cut dito, pwede kang mag-cut dito, because this information or this location of the time-based na frequency representation, makikita natin ay separated by 90 degrees. Di ba? This is 90, this is 180, this is 270, and this is 90 with relation to this one. So pag sinabi natin orthogonal, meaning the other one already can start sending another signal. Kasi pag time na yung one signal ko, okay, one frequency ko is naka-up siya, okay, naka-up siya, yung isa ko naman ay naka-down. So, parang naka-1 to, naka-0 to. Ibig sabihin, hindi sila mag-interfere because the maximum power of these two are totally different. Naka-0 to, naka-0 out, ito naka-1. So, ibig sabihin, pwede na pala ako magpadala ng information dito. Okay? So now, sa isang system, sa isang buong bandwidth na yan, no? Sa isang buong bandwidth na 20 MHz of bandwidth, let's say for LTE muna, kung meron silang ganitong klase ng separation at per standard, it's 15 kHz, no? Makikita natin dito that it can have multiple frequency inside, or what we call the subcarriers. Okay? And the subcarrier spacing is standard at 15 kHz for LTE. Again, for LTE muna tayo kasi gagamitin natin yan. Okay? So ibig sabihin, ang sinasabi lang natin dito, no, pag tinignan natin yung ating domain, this one is a frequency domain, tama? And this one has different frequency. Pag tinignan mo yan on the other dimension, ay, ibang dimension na. Pag tinignan mo yan sa time dimension, okay, pwede pa pala silang paghati-hatiin. Yun yung kaibahan ng frequency or filtered orthogonal frequency division multi-pole access. Makikita natin dito, tingnan natin dito. Pagdating sa OFDM, pwede mong paghiwa-hiwalayin yung user mo based sa time. Okay? Pwede kang time, di ba? At saka frequency, pwede ring frequency and time. Time and frequency din ulit pwede, and so on. So pwede kang, tingnan mo dito, at this time, at this point in time, one user lang. Ay, sorry, at this frequency, no? At this frequency, clear na nga, malabo ulitin ko. Okay. At this frequency, isang user lang. Okay? At this frequency, mayroon akong dalawang user. At this frequency, one user ulit. At this frequency, one user, two user, one user, one user. That is one side of the plane. So pag tinignan natin dito, sa time 0, ilan yung user ko? 1, 2, 3, and 4. Okay? So meaning, I can separate yung users ko both sa time at saka sa frequency na domain. Yun yung tatawag nating orthogonal frequency division multiple access. So ano naman yung tatawag na filtered? No? Pero bago tayo pumunta doon, kung bakit tayo nagkaroon ng 7 symbols dito? Bakit kaya? No? Because everything is related to time. Kasi 15 kilohertz is 15,000 cycles in reference to 1 millisecond. So pag kinonvert natin yan ng 15,000 cycles per 10 millisecond, 1,000 milliseconds. So makikita natin that meron kang given time na 0.00067 milliseconds per cycle. Meaning, pagka nagpadala ko ng information using a 15 kilohertz na frequency, then it will reach yung kanyang wavelength, yung full wavelength niya, no, in 0.066 milliseconds of time. Okay? Kaya pag tinignan mo yan, kung ang isang slot mo per standard ng LTE is 0.5 milliseconds, divide mo yan ng 0.06, nasa 7 yan. Almost 7. Yung mga ibang naiwan na time is usually used for other overhead. Okay? Check nyo baka mamaya. Hindi. Divide nyo lang. So meron kang 1,000 milliseconds, no? And they can be parang pwede silang interchange, di ba? 1,000 milliseconds, divide mo siya ng 15,000 cycles. So ibig sabihin meron kang 0.0067 millisecond per cycle. So ngayon sa buong span, no, meron kang 15,000 na cycles. Kung meron kang 0.5 milliseconds, divide mo ng 0.0666667, diba? Meron kang around 7 or 6 point something. Okay? Kaya nagkakaroon tayo ng, kasi kaya diniscuss ko to kasi magiging critical to on the next slide. No? So clear yun kung bakit tayo nagkaroon ng 7 symbols in the 0.5 milliseconds because of these 15 kilohertz. Bakit? Because on the next slide, using a filtered orthogonal frequency division, multiple access, ang sinasabi natin dito, because of the word filtered. Okay? Filtered is changing. Anong change ko ngayon? Yeah. Nakalike pa. Sir, nakakasunod pa tayo. How many participants do we have? 112. Okay. To all the 112 participants, so please bear with me. So now, ano ang babaguhin ngayon? Am I going to change the structure? The answer is no. We're not changing any structure. We're not changing number of symbols. What we're gonna do is to change the frequency. Kaya tawag siyang filtered. Filtered orthogonal. Filtered meaning changing, you're filtering yung iyong frequency. Diba? Kahit sa music, no? Familiar yung filtering na yan. Gusto mong mag-filter ng high band, filter mo siya. Or kahit sa tuning, no? Meron kasama yan. Filter ka ng lower frequency, filter out, filtered in, di ba? Gumagamit tayo ng mga certain filters to avoid frequencies, can be higher or can be lower. So now, ang sasabi natin dito, timing is everything. Kung wala ka pang pwede ka mag-filter. Okay? So, makikita natin dito na ang sinasabi natin sa filtered, we're changing yung frequency. Okay? Pinifilter natin yung frequency. Now, we're not changing any structure. Okay, yun yung sasabi ko. If you try to look at it, no, tingnan natin dito. 15 kilohertz, basic yan, no, for base yan for 5G. 15 kilohertz, ang number of symbols natin is 14. Bakit 14, sir? Kasi kanina, di ba, pinakita lang natin dito, 7 symbols siya. Okay, pagdating dito is 14 symbols. Okay, binuo lang natin yung buong structure niya. So, meron tayo dito, makita natin dito, 17. Okay? 17, 14 slots, no? Number of OFDM symbols per slot. We have 14. Okay? Makikita natin dito all throughout the system, naka 14 slots sila. Nagbago lang ng number dito sa 12 because of the extended CP, which will not be discussed in this topic, but when say extended CP, we're just adjusting yung time nung delay para yung kasi may mga tinatawag tayong di ba, multiple tawag dito yung nagba-bounce ng mga signal sa mga edge, di ba? So pagka hindi sila mag-arrive at the same time, so binibigyan natin ng time yung signal to arrive para dun sa delay niya para ma-compensate. So now, pagka extended CP, 12 yan, pero nagiging 6 per ano yan per 0.5 milliseconds. Pero para lang maintindihan natin, nasasabi natin, all throughout ng mga filter natin, 15, 30, 60, 120, 240, 480, lahat yan 14. We're not changing any structure. What we're changing is yung frequency. And now, what will happen to time? Check nyo. From 15 kilohertz na naging 1 millisecond, pag nag-change ako to 30 kilohertz, nagiging 500 millisecond. Oh, sorry, micro. And so on and so forth. Okay? Clear pa ba? Clear? We're not changing any structure. We are not changing any structure. We keep the structure. What we did is we filter yung frequency to arrive at different time frame. Okay? So ngayon, makikita natin dito, no, 1 slot, 2 slots, 3 slots, same pa rin yung ating number. Ang pinagbago lang ay, tingnan natin dito, number of slots per subframe. Yan. So from 1, naging 2, naging 4, naging 4, naging 6, naging 8, naging 16, and 32. So now, ang nagbabago dyan is the number of slots per frame. Okay? So pag buong frame na to, mas madaming frame dito as kumpara sa frame dito. Pero kung titingnan mo, yung time na yan is still, on a 1 millisecond time slot, no, nagbabago yung ating OFDM symbol at smaller time lang. Okay? Pero mas madaming symbols ang naipapasok ko at the same thing. So pag tignan natin ulit to, no, para lang malito tayo lalo. Okay, hindi. Biro lang para mas maintindihan natin po pag bumalik tayo sa yung frequency ko. Yan, di ba? So itong frequency na yan ang nagdadala. So sabi ko nga sa inyo, may relasyon ang time sa ating frequency. But the lower the frequency, no, the larger the wavelength na it could get. Malaki yung wavelength niya, pero mas dami ang kinakain niyang oras as compared to this one. Ito yung buong cycle niya, pero mas maliit yung wavelength niya. Okay? So I hope I made myself clear on that, no? Kaya tinatawag siyang filtered orthogonal. Ito yung isa sa mga critical. Because, ano bang kinalaman ng mga filtering na to? Because filtering these things will be used in the types of application ng 5G. Okay? So pag tinignan lang natin, no, yan din yan, number of resource blocks at saka RB, just a representation here. Pero ang critical this one, in this part is makikita natin that we have number of slots per frame. Kaya kung bakit later on ay discuss pa natin. So now, after OFDMA, no, I hope you guys can still bear with me. Give me, I think I have a few more minutes here. Okay. So, MIMO naman is just basically putting up streams, no, with different types of antenna. It's an antenna system. Okay, hindi siya, it's antenna system wherein you put different information. If you are having diversity as a technique, let's say kung medyo hindi maganda yung signal mo, usually the system would do a diversity, meaning sasend yung information at the same scenario with the other antenna. So 101 lang lahat ang papadala na dyan. That's what we call the diversity. Para at least ma-recover mo yung information from here at saka from here. That's why, kung titignan mo, you have a lot of protection when it comes to cellular technology because number one, you have a coding wherein you can protect your information by redundancy. You have a cyclic prefix that would prevent you from getting any delays or prevent you from any synchronization issue when it comes to delay. Kasi meron kang multiple, di ba? Pag nagpadala ka ng signal, pupunta yun sa iba't ibang multipath. Yun yung hanap kong word, multipath. Tapos, meron ka pang diversity in terms of the antenna. So, meaning, binabato mo ng dalawang beses, binabato mo ng sabay yung information on different antennas for you to be able to recover it. Let's say, hindi mo siya narinig dun sa kabilang antenna. So, that's what we call the diversity. If you have a very, or if you have, let's say, average to poor signal, then a diversity can be called out to support yung ganong klase ng requirement. But if you have a very good signal, then you can go for spatial multiplexing. Ang sasabi lang natin dito is that spatial multiplexing is you pre-code yung mga information mo to different antenna so that makikita natin dito that your bitrate would be higher. Kasi tingnan natin dito, no? Same information, okay, 101, same information, mapapadala ko siya. I'm assuming again, 1 bit is 1 second. So, ibig sabihin, mapapadala ko yung information ng 3 bits in 3 seconds. Okay? 3 bits in 3 seconds. Tama? So, that would be 1 bit per second kung titignan natin kasi redundant lang yung kabila. Tama? Okay? So, here naman, makikita natin, Same pa din, with respect to time, 3 bits in a second. So that would mean 3 bits per second. Kaya nagkaroon ka ng mas mabilis na data rate in using spatial multiplexing because you're sending different data into different antenna. Okay, kaya nagiging mas effective to pagka mayroong maganda kang signal or meron kang magandang channel. Yun ang ginagawa lang ng massive MIMO. Ang ibig sabihin ng MIMO would be massive input and massive output. That's why meaning your input you're from transmitter and then output mo is coming from your receiver. Usually, again, pag tinignan mo to, no, it can only happen again sa device level. You have to check your device if it's capable of receiving 4 streams as well. Kasi may mga devices that are only capable of receiving, or well, they can receive, let me check. Sa mga ibang modems, no, na I check na sometimes they can only receive 2. May mga dalawang antena lang sila. I think particular to sa ibang sa mga modems na ang fixed, no. Meron silang dalawang antena and then yun lang yung kaya niyang i-receive. Meaning even if your site is a 4x4 MIMO or let's say it's a 64x64 MIMO, if your device is capable only of receiving 2, then yun lang pwede niyang ilagay. That's why sometimes yung naming nila is MXN, wherein yung the transmit and the N would all will be your X, no. Kung ang system mo ay ganong klase, we call it 4x2 usually. So kung halimbawa yung phone mo, let's say your phone is an old model, pwede yung ano yan, baka 4x1 yan or let's say 2x1, no. And then sa mga antenna din for the baka kasi malito din kayo, meron din tayo tinatawag na N/XM, okay? So i-drawing lang natin. Usually kasi MXN yan, okay? Yan. Ito yung number of antennas ng phone. So meron din tayong tinatawag na NXM. Okay, saan naman ginagamit to? Sa upload. Okay, yan pag-upload, ito pag-download. Okay, so number of antennas mo usually for download nasa maximum ata, makikita niyo yan sa LTE category ng mga devices, no? Sometimes they can go up to 4. Pero usually the antenna for uplink is kadalasan 1 yan. Bakit? Kasi kung sa device yan, kung phone yan, because of the limitation on the power and because they made it mobile and mobility is the key, no? Kaya nililimit nila yung transmit mo into 1 stream lang para hindi ka agad maubusan ng baterya. Okay, so increase capacity. So makikita lang natin dito, no, if you increase the capacity, then you'll be able to serve yung mga block. And alam naman natin, no, pagka balikan lang natin ulit, this one, you will have more number of slots per frame. Okay? Kaya mas madami kang pwedeng isakay given na let's say kung ang meron tayong tinatawag na TTI or wherein ito yung ini-schedule ng system for you to be able to access the network kasi nga everything is time, no? And it's being run by micro and milliseconds. So mas madami kang slots per frame. So ito na sasabi natin, if you have bigger bandwidth, you will be able to serve more. Okay? So yung mga dati mong pumupula dyan sa dulo, if you have capacity, because these are not in good RF condition, okay, let's assume, kasi nasa malayo sila, then the problem with them is, yung capacity na kakainin nila would be, medyo pangit na lalo na kung dulo ka talaga. Okay, so now, if you have a bit bigger bandwidth, no, you'll be served like this one. Pwede kang ma-cover na mas madami. Now, another thing, using a beamforming technique, no, pwede ka using the beamforming technique ng 5G, then they can, with good correlation, they can pan yung mga beams natin towards certain users. And makikita natin dito that each of the beams will have different resource din. So pagka iba't ibang resource mo, expect that there would be a maximum capacity that would be distributed to the users. Now, makita din natin dito, no, one good thing about the increased capacity is that, pag tinignan natin dito, diba? There are devices kasi that would require very minimal of data pagdating sa later pag-usapan natin yan, no. Pakita ko na lang later. Now, on the quicker response, ang kagandahan kasi dito, no, with the filtered OFDMA, makikita natin that every time we filter the frequency, then the time is relevant. So imagine, no, kung ilang seconds na lang ang kailangan mong kainin to send and receive information given this 120 kilohertz of bandwidth. So in terms of pi rate, no, mas mabilis talaga siyang mag-respond as compared to, let's say, 1 millisecond na 15 kilohertz. More than that, sa structure kasi ni 5G, no, there are some other applications that could help deliver yung low latency by putting up your edge or putting your core into the edge. Okay, so meaning kung ito yung system mo, instead of going to the core services, then you can do a core in this area. So meron tayong tinatawag na ito control plane tsaka user plane separation. These are other parts of core functions. Kaya meron kang low latency dyan because let's say this one, low latency, no? Pwede kang kumuha ng information coming from here through cloud. So mas mabilis ang information as compared kung let's say kung IoT ang application mo, then you would have to go to pass through here, no? And kung gusto mo ng massive broadband, then other applications. Meron kang user and control plane separation. Meron ka ding tinatawag na virtual network functions, no? Ito yung pinaka tinitignan nila for 5G. And then yung mga software-defined network, network function virtualization, and so on for 5G core. Okay. So now, for the benefits of 5G, balikan lang natin, no? These are the applications na. So for the target of 10 Gbps, meron tayong tatawag na EMBB or Enhanced Mobile Broadband. Okay. So ito yung mga information na kung you want a bigger bandwidth, no? Because of this 10 Gbps and bandwidth-wise, meron kang spectrum that will be capable of delivering higher speeds, then andyan si EMBB. Now, for the increased capacity, we have the MMTC or the Massive Machine Type Communication that would cater 1 million devices per square kilometer per cell. So, ang sasabi lang natin dito, no, if I can schedule here, no, here, I can schedule more because of this filtered OFDMA, because of the number of slots per frame. Kasi ang standard ng LTE, no, again, kung i-connect mo sila sa NB-IoT ng LTE, the bandwidth would be this one sa standard. Pero pagka, let's say, kung gagamit ka ng other application, then you can have more slots as compared to the LTE. Okay. Kaya makikita natin dito, no, here you can have 1 million devices, and then you have quicker response of 1 millisecond because of the application of MEC, control and user plane separation, and yun nga, because of the filtered OFDMA, makikita natin that the time is changed per slot. So now, benefits of 5G, again, yun nga, in terms of LTE, 10 times faster, bigger capacity, and more responsive compared to LTE. Some applications and use cases, security and sustainability, using massive machine type communication. You can deploy multiple sensors and then connect them to 5G na 1 million devices capacity per square kilometer. And you have for personal skills and development like AR, VR, diba? Yung mga applications natin, maybe sooner or later we can have the hologram or VR Facebook, VR communication, and so on. AR, VR. For health, no, can be telemedicine or teleoperation. Industries, yung mga driverless car. For industries, manufacturing, and intelligent city, and so on. So now, for the early stages ng 5G, ito lang yung tanong kanina, no? What are the difference of SA and NSA na pinakita natin kanina? This one is what we call the NSA. Drawing ko, NSA. Pag sinabi natin NSA, this would mean non-standalone. And this one is standalone. For the early stages of 5G, the SA is still being developed, the protocols, diba, parang batas yan eh. If you're going to make a law, then you have to put up the IRR or implementing rules and regulation. Same with the standardization ng lahat ng cellular technology. They have to put the protocols, etc. So for SA, I think it's yet to be released for 5G rollout. So now, makikita natin dito that NSA would need an LTE for it to connect to 5G. Okay, kailangan niya ng LTE before connecting to 5G. Okay, makikita natin na lahat ng signaling mo dumadaan kay LTE muna, then connect sa 4G EPC, and then yung 5G new radio mo or yung access mo is connected as well sa 4G EPC. At yung data natin, dumadaan siya kay 5G din. Okay? So ang question is, meron ba dumadaan kay 4G LTE na data coming from the 5G na bits? Yes, if you activate the dual connectivity. Okay? Pwede dumaan din yan if you connect yung ating dual connectivity na feature. Okay, as part of the protocol then. So for the SA naman, totally different sila. Signaling and control and data plane would pass through 4G and separately for 5G. Magkakaroon na siya ng sarili niyang core. Okay, so kaya pag tinignan natin yung phone natin, dapat it should be able to support both NSA at saka SA. Because for the early stages, we are on the NSA at saka moving forward, no, with the development from 3GPP and the manufacturer and yung tawag nating TSG or Technical Support Group for the core and terminals, for the systems and aspect and services, tapos yung radio access network would be able to arrive at the SA. Okay? So I hope nasagot natin yung tanong ni Sir na ano ba yung NSA tsaka SA. Non-standalone and standalone. Ganito yung kanyang architecture. Pag NSA, lagi dadaan muna kay 4G for signaling, authentication, validation, and balik ka dito, then you will be able to create a link or a bearer link to the 5G to get your information or to get your data. Again, the bandwidth of the 100 MHz at saka yung 800 MHz are nandito. Nandito sila sa link na to. Okay, wala sila dito. Because LTE again, maximum nito is 20 MHz. So sooner or later, magagamit din natin yung ating SA. Okay. Now, isa pang challenge, no, I think this would be the last slide, no? Give me 2 more minutes. So makikita natin dito, yung ginamit natin for 5G, usually nasa 3.5 GHz sila internationally. Madaming gumagamit ng itong frequency na ito. Meaning, dahil nga mas mataas yung frequency niya, or mas mataas yung mas mataas nga yung frequency, ang nangyayari is you have a smaller or shorter na wavelength. Meaning, yung distance mo would be shortened as well or will be shrink, no? Or mas maliit talaga yung coverage niya. Makikita natin dito, no? This is a 5G coverage for, this one is for your DL and this one is for your UL ng 3.5. Okay. I-kulayan natin. Okay. This orange one is your UL. Okay. Bakit po magkaiba? Can anybody from the team can answer that? Bakit magkaiba ang UL tsaka DL? Because, again, when we operate at frequencies, no, we are also dealing with power. Okay, and power is relevant to the information or it's relevant to the coverage because yung ating tatawag na base station transmitter or yung ating cell site, no, mas common term, pag nagbabato yun ng signal, yes, it can shout because it has enough power because it's connected to the AC. As compared to your phone is running on battery. Kaya mas maliit yung kanyang power. So I think that's around 23 milliwatts of power, no, pagkapabalik. Now, gumagamit pa siya ng mas mataas na frequency. That's why when you do uplink, no, nasa hanggang dito ka lang. When you do uplink for 3.5 GHz, itong pulang to. Let me add that one. Or palitan ko ng blue. Pag nag-uplink ka, okay, dito ka lang. Ay, hindi pala makikita, no. Let me try another color. So, pag nag-uplink ka, hanggang dito ka lang. Ito yung edge mo ng uplink mo. Okay? Because you are limited by the power of your phone. So, ano mangyari dito pag nandito ka na, hindi ka na makaka-connect back to your site? Yes, but then, if you will use yung tinatawag nating SUL or supplementary uplink at supplementary downlink, no? Pero in this case, sa drawing natin, supplementary uplink will be used. Makikita natin that your coverage for uplink will now be increased because of this lower frequency. That's why we call it supplementary uplink. Okay, so ngayon yung dati mong upload dito, no, pwede mo nang umabot hanggang dito, closing a gap of 13.7 dB based on simulation. Okay, kaya usually itong mga to, okay, nagko-site sila or nag-stay sila. This is not the main reason. The main reason for having them in one site is because of the NSA structure or architecture. Okay, hindi dahil sa pag binalikan natin to, sorry, yan. 'Di ba ito? Nagko-co-site si 4G tsaka si 5G para magkaroon ka ng control plane. Okay? Pero again, to have it a more useful, no, frequency for 5G, this will be called yung coupling at saka decoupling na tinatawag. Okay, decoupling and coupling is using lower frequencies to help the phone or the device to do uplink, particularly for the areas where uplink for mobile phone in 5G will not be capable already or will not be able na, no, because of the limitation on the power of the device. Okay. Sir, kasali po ba yung on-site equipment for, sir, kasali po ba dito yung on-site equipments for 5G like AAU, BBU? Sa discussion natin, Sir Chris, hindi, no? Because these are specific to network and will not be covering equipment of the site. Okay, so ito na yung ito yung tinatawag nating supplementary uplink. 1.8 gigahertz pwede ang gamitin. Kaya makikita natin, no? Again, balikan lang natin. Let's clear these things up. Clear all drawings. Okay. Yan. Okay. Ito yung mga list ng mga supplementary uplink. You can go 1800, you can go 900, and so on and so forth. Depende so kung anong i-allow ng governing body ng local operator. In terms of handover performance, ano ang improvement sa ma-experience sa 5G? In terms of handover performance, what do you mean, sir, na handover? Handover still be the same, no? If you are on mobile device, then you would be able to camp as long as you have a nearby site, no? Mali pala, dito tayo dun sa realize. So pag sabi natin handover, no, para sa mga non-telco friends natin here and listeners, pag sabi natin handover kasi, so may mga areas na let's say hindi ka covered, no? There are two sites that are within the boundary, so that pagka lumipat ka sa kabila, no, somebody will, or some site or the neighboring site would be able to get yung information from the user, and it would be able to camp on that and get the data. So same pa din naman, no, the sites are linked up between the two and they can communicate to each other. So in terms of handover, no, performance will still be same. Pero hindi ko lang kung anong performance hanap natin, sir. Is it drop call ba or handover failure rate, soft handover, hard handover, no? Hindi sila part ng discussion natin due to the technicalities of it. Due to the demand and excitement, sige, bago natin sagutin yun, no? So I think that would be the last slide, Miss Jessica and Miss Donna. So again, ito yung ating tatawag na decoupling as part of the challenge, no? But again, it can be resolved by using the 1.8 gigahertz or other supplementary uplink frequency. So questions. Questions muna bago, thank you. So natin yung mga tanong. Due to the demand and excitement of 5G, which will be deployed sooner or later, and need for such service in dense urban, we cannot avoid skyscrapers, building campuses, malls, and other high-rise structures that can be also considered as obstruction aside from outdoor. Can elaborate more on penetration rates and these frequencies as per data sheets, test bed case studies, in scenario in GC. Good question, sir. Okay, due to the excitement of 5G, no? Again, tama po kayo. We cannot avoid skyscrapers. That's why it's part of the planning. Okay, of course, every telco has their own planning team to design what would be the optimal coverage for all. And we know then for a fact that there would be a hetero network, meaning we have different types of cells. We have the macro cell that could cover bigger range. Let me annotate, no? There are cells, okay? There are cells that are really big, no? That can cover yung ating mga areas, okay? Or tapos paano kung may building naman dito? Of course, no, yung signal mo from here, mabubuyan, magiging ganyan na lang. So they can put more sites in this area as part of their planning. And kung halimbawa itong part na to maliit lang siya and then block pa din siya ng next signal, then they can put smaller versions of the sites. We have the small cells kung tawagin. And I think these are prominent part of the solution as well. Na pwede silang gumamit ng mga tinatawag nilang small cells family. At I think may mga 5G ready na or 5G capable na small cells na in-offer ang ibang mga manufacturers. And then, ano pa ba yung kasunod ng tanong niya? Can you elaborate more on penetration rates? Yes, we can elaborate more on that, no? I can share you one. Let me get it. Pero definitely, if you will use higher frequencies like a millimetric wave, then this type of equipment that would run on these frequencies would have a very short coverage, like maybe 50 to 100 meters. Well, it depends really on the type of application. No, if you're covering a BGC hotspot area, then you could put really small cells on that area. But again, it depends on the telco, on what type of service they would want to deliver on those particular areas. Okay. Tapos, ano ba yung question ni sir? Penetration rates, yes, I can share you as well. Pero nasa 18 to 21 dB. Just for sharing lang, no? Para lang makita din nila. I-stop sharing. Let me pull another data lang, no? Para lang makita lang natin yung numbers. Thank you, team. Thank you for the participants. I really enjoyed sharing with you kasi you're very interactive, no? And I think you really wanted to learn about yung 5G natin. Sir, yung question mo regarding dun sa penetration rate, I'm not sure on what penetration rates you're telling, no? Hindi ko alam kung is it mobile penetration rate, meaning kung gaano kadaming devices ang makikita natin yun yung. Pero what I can share with you on the technicalities of 5G is this one, no? I think magiging familiar din naman tayo dito since at least for telco engineers, no? Ito. So makikita natin dito na there are two types of possible behavior for 3.5 and 28 gigahertz. So makikita natin dito, no, yung path loss mo as you move along, then it would be really bigger. So given the bigger path loss, pag sabi ng path loss, no, ito yung signal mo, binato mo sa hangin yan, binato mo sa over the air, humihina yan because of the path it's taking through. And alam natin, because these are operating at very high frequency, yung konting galaw lang ng behavior ng frequency na tumatagos or ng power over such distance, tumataas din siya. So makikita natin here, if you are lost or line of sight, no, ito yung magiging behavior niya. So around 70 to 100 dB. No? At saka meron silang 18 dB difference between the two. And so for penetration naman, ito yung pagpasok niya sa loob ng building. That's what we call the penetration. So depende kung anong type ng material, based on the simulation, meron tayong standard multilayer glass at saka coated glass. Again, yung materials na ginamit dyan, then we have to check din as well, no? I don't have the details right now, pero makikita natin with coated glass, more reflection would manifest. Kaya makikita natin yung penetration loss niya mataas as compared dun sa standard multilayer glass. Oh, sir, I have a question. Sabi niya, just to help others understand that is 5G, aside from the fact that 5G news, what else make 5G safe enough to use residential, especially in terms of power density? Yung question mo is yung sa kay Sir Marvin De Pedro, no? To answer number one is we have the inverse square law. Yun yung pinaka-basic na mathematical formula na pwede natin gamitin, that your power or nagdi-distribute siya as 1 over r squared. So dun sa distance mo, squared mo. So yun yung magiging possible power distribution niya on that particular area. So, tama ka, power density can become less and less as it moves along or it moves away from the site. Regarding IoT, are 5G modules ready available in the Philippines? In my surf and study, no, I think these are not yet available in the Philippines. So you can check more. Even outside ng bansa, no, I think they're not yet ready for 5G modules IoT because we have yet to wait for the protocol that they have to release pa for MMTC or massive IoT. Is 5G already implemented in the Philippines? Yes, sir. Philippines is the third next to Japan and Korea, and we are first, yeah. third pala, sorry. Next to Japan and Korea. And we have them already. Both Globe and Smart. Si Smart alam ko medyo maingay siya on I mean meron silang mga gaming na ini-stream using 5G network. Sir, line of sight po ba ang 5G? As we can see on the behavior kanina, yes, basically it's really it can actually it's best to have a line of sight, of course, no, kasi you will have a better power, but meron din tayong tinatawag na non-loss or non nga lang mas pangit yung experience mo because of the degradation of signal or what we call the path loss and penetration loss. Sir, how can affect 5G? Ay, sige po ba?
Sir Derek,
Yeah.
medyo marami ata po yung concerns nila. Can we collect it na lang po? Para.
Sure. Or you want me to answer last two questions?
Sige po. Go lang po.
I-scan ko lang yung mga bless. Rain should syempre rain can affect 5G as well because they are operating at millimetric, lalo na kung millimetric yan. It can bend or refract, no? Depende sa type ng rain kung gaano ka. Wala pala akong video, no? Ayan. What's the ideal height to have a good depend yung pagka when it comes to planning, no, in terms of 5G, anong frequency gagamitin mo, anong power, so depende talaga sa planner ng telco kung ano yung ideal height. And syempre base nila sa simulation nila kung anong type ng morphology ng area, is it dense urban, depende talaga yan sa cluster type kung tawagin. I have what do you think is wrong in this case? We are in the 6th floor and tends to change 4G signal. What do you think is wrong in this case? I have a portable 5G router. Maybe the coverage can be and loss or yung penetration natin to the building. No, we can put the modem outside if it's safe, no, to put it outside. And kung pwede siyang i-cover ng ulan or pwede siyang ma-cover ng ulan and heat, no, better kung lagyan natin sa labas. Because 5G, if it operates at higher frequency, then mataas yung chance na yung signal mo sa dulo ay mahina. Sir, what does 5G network? Sir, does 5G network uses fiber optics? If yes, what is the role of the fiber optics? 5G again, 5G is wireless. It's a wireless technology that connects from the tower. Nakita natin yung tower na may antenna yan, and then you connect yung device natin to the device. So now, if you want to ask ano yung role ng fiber optics in 5G, then it can support yung backhaul natin papunta sa core. So fiber optics, given the higher capacity, would support yung higher capability ng access network natin going to the core. So yan, I think I've answered lahat.
Sige po. For other concerns siguro, sir, collect na lang din namin para matanong din sa inyo. So, yun po. Thank you for your very educational presentation, sir.
Sure.
Medyo daming technical information po, no? Tapos, some of it will bring us back in our college days.
Yes.
Tapos, most of it, additional information talaga for professionally. Tapos, even not non-telco or non-ECE. So, may mga additional information po na pulot dun sa educational presentation niyo, sir. Thank you, Sir Derek.
Sure.
Okay, to continue po our webinar, let's have our PRC update po from our chairman and members of the Board of Electronics Engineering, Dr. Alner Detalia, Engineer Herminio Orbe, Engineer Enrico Claro Del Moro. Good evening, sir. Maybe we can start with Dr. Alner Detalia po.
Hello, good evening.
Good evening.
I really appreciate the the lecture given. And thank you for this very informative lecture. Well, in as far as PRC update is concerned, I'd like to emphasize the establishment of the specialized group for the career progression and specialization. So uh, this particular topic is a preload for the topic that's going to be delivered for the telecom specialization. So continue doing this, and let's have it in the future na ma-organize na talaga tong mga specialized group natin for career progression and specialization. So far, yun lang yung immediate na ano natin. We need to establish the specialized groups for us to really take off on this particular career progression and specialization. So probably other members of the board has something to say about this or add another inputs in as far as PRC concerned. Unless if there are questions directed to us, we can accommodate some. So I'll give time to the other members of the board if they have something to say also.
Wala naman tayong bagong information sa PRC besides the electronic COGS. No? Yun lang yung one natin ngayon eh. Yung pinakabago natin yung EC acceptance ng PRC on the ECOGS. Si Hermie, baka meron siyang inputs. Hermie, nakamute ka.
Automatic pala nakamute. Okay. So one of the latest maybe is the CPDAS. All the CPD providers will have to use now the online processing. So there will be some capacity building on this. It will be announced later, but initially the CPDAS capacity building will be done next week, I think. We have a schedule for the boards, and then later on for the providers, and down the line. So maybe the providers, specifically IECEP, maybe all the governors will be there or should be present so that they will know the CPDAS. So I think that's it. And then the October, I'm sure they know it already. The October exam will not be pushed through. What else? I think that's the latest as far as the PRC is concerned. Of course, the CPSP, it's ongoing project. But by the way, there is a project, Rico, you are sharing it, the health, what they call this, the health facilities standards. So maybe you can initially give them some inputs or
okay.
Yeah.
Okay, so there's a project of the PRC with regards to new design standards for health facilities. And currently we have formed a technical working group, and including the board of ECE plus 4 more engineers. No? Dalawa dalawa on biomedicals, isa on clean room, and another one sa general building electronics. No? So we are coming up with some recommendations that will be submitted to the Department of Health for consideration on the construction of health facilities. So yun yung isang gagawin namin hopefully in 1 month's time. No?
Palagay ko, bilisan natin yan kasi the mechanical group has already one, electrical, maybe even earlier, less than a month if we can do it. Anyway, your technical working group are, I think, competent to do the new facility, the standards. So maybe just push push all these members.
Oh, tutulak ko kayong dalawa. May nakita akong question dito sa chat from Marvin De Pedro asking about the acceptance of applications for PECE. No? So, yung application sa PECE, hindi naman niya nag-i-stop. If you want to apply for a PECE, then you can do so. No? Gawin nyo yung kumpletuhin nyo yung credentials nyo, and then submit nyo sa PRC. Nobody is stopping you to submit one. No? Maski na nandito tayo sa pandemic. Siyempre, dapat pag sinubmit mo yun, mag-ingat ka. No? So, wala pang online submission to. You have to submit physically your yung physical application. No? Yung hard copies.
Maybe if I may suggest,
yes.
Para yung kanilang let's say NBI at saka i-delay nila yung submission kasi sayang naman pagka na-expire, hindi na magiging valid. So maybe if there is already a schedule for your interview, then it is time you submit your NBI and ano pa yung mga kailangan nila, yung na-expire. So, yun lang. Pero you have to submit all the required document para ma-schedule. And hopefully, if we can agree with the electrical, mechanical, and of course the electronics to do a what we call the online interview or online exam. So, hindi pa ano yan, hindi pa final yan, but we are talking with the electrical and mechanical group. So maybe next week or we can schedule another meeting to finalize, because we need to harmonize our procedure, and then we will recommend this to the commission for approval. Otherwise, mag-aantay tayo. So I think that's the latest, except baka meron si chairman na may nakuha bagong information about this one.
Well, so far yun lang yung mga information natin, but in addition also to PEC interview, take note that marami tayong backlogs kasi because of this pandemic, so if you are going to submit your application for PEC upgrading, siguro naka-queue kayo, so yung yung naunang na-submit or yung naka-schedule na hindi natuloy, yun yung uunahin natin. So take note also of that, and so the schedule also of your interview will matter. As what mentioned by Engineer Orbe, there is a possibility na yung mga other documents na kailangan like NBI clearance and itong mga COGS probably ma-expire, i-anticipate mo na lang yon kasi ganun talaga, marami tayong backlogs ngayon, na dapat nating uunahin. But anyway, I'd like to encourage you to submit lang your documents, but the advice would be anticipate na there's a possibility na mag-expire talaga yung NBI mo at saka yung COGS mo, so be ready on that. Kasi wala tayong control sa time. So yun lang. Okay.
Walang tanong.
Okay na po.
May question pa rito. Okay, ano? Sino ba to? Nabasa ko rito. Engineer Michael Stephen Gorospe. No? Sir, does the BCE have a position on the EE bill na file sa Senate?
Yeah, si Chairman sumagot.
Ako muna. Ako muna
sige,
magsasalita
go,
si Chairman. Okay. For the EE bill na na-file ni Senator Lacson, nagkaroon ng first reading, but of course, yung first reading is a en banc session ng Senate. Sila lang yung nag-meeting na yun. No? So, after the first meeting, the recommendation is to submit the EE bill to the commission, the Committee on Civil Service and Professional Regulation, headed by Senator, if I'm not mistaken, Senator Ramon Bong Revilla. So, sinabmit yon, ipinasa yon pala sa committee ni Senator Revilla last December 2019. And pag tinignan natin yung website ng Senate, wala pang action after that. I would presume kasi hindi siya urgent at meron tayong ganitong pandemic. So with regards to the Senate, yun yung status nung EE bill, no, na nagkaroon recently ng issue sa ating social media. Yan, si Chairman na.
Yeah, okay. So eventually magkaroon tayo ng position with regards to that particular issue. But the thing is, as what Engineer Moro is saying, so far wala pang dumating na notice from Senate sa PRC para maumpisahan yung public hearing. So I would like to encourage other groups to file their own position also, and let PRC give also a copy sa PRC, so that in the case na ma-delay yung communication from the Senate, at least mayroon ng ibang position with regards to this EE bill issue ang nahawak si PRC para maumpisahan na rin yung discussion on that particular issue. Kasi pag hindi rin kayo magbigay o walang grupo na magbigay ng position, although ibigay diyan sa Senate, but siguro mas mabuti na bigyan din ng kopya si PRC so that PRC will be aware of this particular issue, because as of this time wala pang na-transmit na communication from the Senate to PRC. So ibig sabihin hindi pa yan maumpisahan yung discussion with regards to that particular issue. So para mapabilis yan, kung sino yung grupo na like IECEP, kung may position papers na isasubmit doon sa office ni Senator Lacson, I would like to advise na bigyan din ng kopya si PRC so that PRC will be aware of that and then maumpisahan yung discussion regarding that particular issue. But eventually, and as far as the board is concerned, ay talagang magbibigay tayo ng position with regards to that.
Yeah, actually, direct answer to the question kung gagawa ng position paper ang board, gagawa ang board.
Gagawa.
On top of the PRC position. So remember that PRC will prepare a position paper also once they receive the request from the Senate. But even without the request, all concerned parties should prepare a position paper para medyo malakas yung dating natin. Not only one will make a position paper. Siguro para if we can do so many position papers para at least alam ng Senate na talagang we have questions on that bill. So as many as group, even individual can also prepare a position paper or maybe a complaint or a complaint letter or whatever you call it. So hanggang marami mas maigi. So but definitely the board will have a position on top of the PRC position.
Pwede rin itong Radio Engineering Circle.
Yeah, radio engineering
Yan.
can prepare a position paper or even a small group.
IECEP, ECE Foundation, yung PACE.
Yeah, even the chapter.
Even the chapter.
Even the chapter. Kahit na pare-parehas yung position paper, as long as
marami.
Marami. Important, paramihan na itong kailangan natin eh. I'm sure we have one common position, pero it can be said in different way, So isang position natin, pero on a different approach. Okay?
Of course, pag gumawa po tayo ng position paper natin, dapat meron namang respeto, doon sa author ng e-bill, which is Senator Lacson. Hindi yung kukontrahin mo lang straightforward yung e-bill. Dapat kung meron tayong disagreement on one item, dapat meron tayong malinaw na proposal. Hindi pwede yung hanging.
Yeah.
Hindi pwede yung ayaw po namin ito.
That is a very good.
Dapat po ganito. Dapat ganito.
Yeah. I think a very good point. Magandang point 'yon. We have to respect. So kailangan may respect yung ating position. That is a very good point. At least na-emphasize mo 'yan to everybody. Dapat alam nila. Hindi tayo pwedeng yung disrespectful lalo na sa mga high-ranking officials. Very good.
Okay. Meron pa ba?
Nakikita ni Rico yung mga chat sa chat group. Meron pa ba, Rico? Doon na, meron pa ba nakikita kayo dyan? Wala na? So, ibig sabihin...
Parang simple na question na lang po. How much CPD points do I need to apply for PECE? And then, may plano pa bang taasan ang minimum requirements for medical equipment technician sa mga government hospital, like requiring at least ECT?
Isasama namin sa namin yan, sa proposal namin dun sa new health facilities. Kasi ako from my own understanding, ang na-define ni DOH ay technician lang. Hanggang technician. Tapos, hindi pa nga yata guaranteed na ECT. Basta yung create nilang position for a biomed personnel is a technician. So, yung isang may gusto naming gawing proposal ay dapat meron din siyang at least engineer man lang na position. Hindi lang technician. Kasi hina-hire nila as technician, engineer din natin.
Yung CPD requirements naman for PECE application, indirectly hindi tayo nagre-require ng CPD. Now, what we require is valid license, di ba? So yung validity ng lisensya mo, yun yung nag-require ng CPD. Okay, so indirect yung at saka yung COGS, Minsan mayroon ding CPD requirements yun. But as far as the application for PECE is concerned, yun lang yung hinahanap natin, valid license and COGS. But those documents, kailangan mo ng CPD. Okay.
Thank you po.
Wala na naman po siguro mga concerns. Wala na po kami nakikita mga questions. Okay po. Thank you po, Sir Herminio Orbes, Sir Alnar Detalya, and Sir Enrico.
May nakita pa ako isa. Ano raw update sa e-sign and seal? Siguro ang tarong ibig niya sabihin dito, electronic sign and seal. So, wala pa pong update dyan. At hindi pa naman yata, pwede natin tanongin si Engineer Agatep kasi member siya ng National Building Code Committee. Board of, ano ba yun? Board of
Consultants.
Consultants, Board of Consultants ng NBC. Hindi, alam ko hindi nila ito napapag-usapan yung electronic sign and seal. No? Unang-una, kung tatanggapin yan, hindi din natin alam kung anong klaseng electronic signature yung tatanggapin nila. No? Kasi ngayon, ang defined lang sa gobyerno natin yung ini-issue ng DICT. So hindi pwede yung scan copy ng pirma tapos ilalagay mo doon. Tapos paano yung seal? Sabihin, physically walang seal, di ba? It's something na hindi natin siguro hindi nagpo-progress. No? And further to that, ano nga ba yung nabanggit ko rito? Electronic signature. Sa design yun, una sa design. Halimbawa, kung pipirma ka naman doon sa as-built plan, pwede bang electronic signature lang yon? Maski hindi mo nakita yung facility, pipirmahan mo. No? So kasi pag as-built plan, ang premise nun, na-inspect mo yung project. No? So hindi pwedeng distance yun. Hindi pwedeng distance sa bahay ka. Hindi pwedeng work from home. Unless otherwise, gumamit ka ng drone para mag-inspect o may camera, para makikita mo yung mga items na gusto mong i-check. Kung halimbawa, nag-punch list ka, tingnan mo lahat ng locations bago mo siya pipirmahan. So yun yung isang bagay kasi na missing dun sa pagpipirma ng mga plano, lalo na dun sa as-built. Yung as-built, pirma na lang ng pirma yung ibang PCE natin without actually looking at the finished project. Kung totoo yung drawing na yon as compared mo doon sa physical status ng pinirmahan nilang project. So as of now, wala pa yan. Walang linaw yan.
Yeah. Okay. My personal take also on that. Di ba ang sinasabi ng batas, sign and seal. So hindi talaga pwedeng paghiwalayin yon. Yung sign siguro, pwede natin ma-manage yun. However, yung electronic seal, may legal implication yun. Kasi sa batas, dry seal yung naka-emphasize. No?
Kailangan nararamdaman ng daliri yun.
So, yun nga, may legal implication yun. Kaya siguro hindi yun napaprogress. Kasi yung signature siguro okay yun, we can manage that. Pero yung seal, medyo hirap nating gawing electronics yun. No? Kasi dry seal yung naka-specify sa batas. So, tapos, ang nakasulat pa talaga doon, sign and seal. Hindi lang pwedeng seal, hindi lang rin pwedeng sign, but both. No? So, kaya mahirap. No? Anyway, so yun yung rason doon na medyo natagalan.
Siguro in the absence of any resolution from the government agency, baka hindi i-allow yan. You need some legal basis para magkaroon ng e-signature. In fact, when you ask for a notary public, yung mga attorney, actually mga attorney, we have done that sa PRC. Hindi tinatanggap ng electronic signature. So on the same logic, hindi rin siguro tatanggapin ng gobyerno yung ganong klase. Unless there is a resolution allowing for the e-signature. So even sa PRC, there was a resolution to that effect. Only specific papers can be signed with e-signature. So merong resolution na gano'n. Okay.
Okay.
Thank you po ng marami sa inyo. Miss Jessica?
Yes po. Thank you po ulit. So, to formally close lang po siguro tong webinar natin, may we have Engineer Rico po for our closing remarks.
Maganda closing remark niya. Maganda yung sombrero niya. Tiyo mo yung sombrero.
Okay yan. Hindi, naka-sombrero kasi naka-quarantine cut ako yan. Nagpagupit ako, nagpagupit ako kahapon eh.
Kanya pala.
Nagpagupit ako kahapon. Ang init kasi kahapon. Ano? So, I have to congratulate again IECEP Mindoro for launching your second. No? This is your second webinar. And truly so, yung talagang forte nyo is on telecoms. No? And talagang akmang-akma sa panahon. No? Dahil ang dito, telecoms ay nakakuha na ng prangkisa mula sa Kongreso. So, dire-diretso na yung kanilang pag-operate. And for sure, mag-hire to ng marami dahil ang laki nung kanilang hahabulin na performance, no, na kailangan nilang maipakita sa gobyerno, no, dahil yun yung pinangako nila. Otherwise, kung hindi nila matutupad yon, mafo-forfeit nila yung kanilang napakalaking pera, no? Mawawala sa kanila yung napakalaking pera. And for sure, mag-hire sila ng maraming tao, and it's very good that your seminars now are on telecoms dahil tamang-tama sa panahon, lalong-lalo na ngayon na yung ibang schools nag-start na ng online classes, and yung public schools natin will start next month, officially next month, no, October. And importante talaga yung internet services na kasama nitong ating telecom system. Ramdam na yung internet service sa Pilipinas, no? Wala pa yung public schools, private pa lang yung nag-start ng online classes at mga colleges, pero nakikita mo na talagang bumagal na yung internet natin, no? Lalong-lalo na kung meron sa isang bahay, merong 2, 3, 4 na estudyante sa isang bahay, magsasuffer talaga yung internet sa bahay. No? So kung yung tatay pa ay nag-gaming, kawawa. No? Huwag muna mag-gaming yung tatay kung may mga batang nag-aaral, no, naka-online. And again, IECEP Mindoro is very fortunate to have sponsors, no? Andyan si Gerhard, andyan si Patrick, at yung mga speakers nyo ay kasamahan talaga nila, no? Taga-Globe. Hindi naman siguro kayo bias, no? Pero yun ang available resources eh. Yun ang available resources nyo, and it's just right that you tap the resources available to you, no? So, sorry na lang yung ibang telco kung hindi sila nakakasama dito sa webinar ng IECEP Mindoro, but hindi naman yung siguro sila pipigilan o sila naman yung mag-volunteer, no, na pwede po ba sa pangatlong session nyo kami naman o kaya pang-4, pang-5. Siguro pwede nyo naman silang pagbigyan. And I'm looking forward that the next webinar of IECEP Mindoro will also go this way, no? Actually, yung ginagawa nyo nga is something na hindi nagagawa ng ibang local chapters kasi you are conducting your webinars by yourself, no? Of course, pikatulong kayo yung Radio Engineering Circle, but they're also local, no? Unlike yung ibang local chapters dito ng IECEP, ang kanilang nakikipag-collaborate sila sa international chapters, no? Yun ang usog-uso ngayon eh. Local chapter plus international chapter, no? Kaya dalawang local chapter, isang international chapter, may niluluto pa yata gano'n, no? And yung at least sa inyo, local and officially non-IECEP pa, no? Yung REC. Officially siya, hindi siya IECEP. And it is good that you venture into this activity, and the Board of ECs will be with you kung basta kukumbidahin nyo kami, no? If you continue to invite us, then we can attend here as much as we can. Good evening po, and let us all stay safe.
Thank you, sir. Stay safe din po. Um, for another closing remarks po from our engineer Donna, our governor of IECEP Mindoro po.
Ayan, hello po uli. Actually, ito po yung pinaka-relax na webinar namin. Compare po doon sa nakaraan. And pinaka-relax pero napakadaming information na napulot. So, we also believe na lahat ng participants tonight is maraming natutunan. Thank you very much po to our speaker, Engineer Derrick, and of course to our BECE. Maraming salamat po. And syempre, hindi namin makakalimutan pasalamatan yung REC family na sobrang, yung support po talaga sa amin is 101%. So thank you po talaga. But guys, before you leave, make sure you fill out the evaluation and feedback form. In behalf of IECEP Mindoro chapter, thank you all for joining us tonight. We hope to see you all again in our next webinar. We promise that we have. Just like and follow us on our Facebook page, IECEP Mindoro chapter. And if you want to join IECEP Mindoro chapter, we encourage you to direct message us on our FB page or just email us in chapter@icepmindoro.org.ph. So we will guide and help you as soon as possible. Again, thank you all. God bless and keep safe.
Thank you po. So that's our webinar po for tonight. Thank you all for attending again.
Pwede ba tayong mag-group picture?
Pwede.
Bago tayo mag-hiwa-hiwalay?
Prepared po si Sir Enrico.
Oh, ang ganda ng hati. Medyo Enrico.
Oh, galing kwan doon. Galing
Middle East.
Saudi ba to? Saudi.
Sa Middle East yan eh.
Kuya Alben, pwedeng
Oo.
ikaw din, screenshot tayo.
Wala pang camera yung iba.
Si Engineer
Si Engineer Tan, wala naka ano lang, nakatato.
Engineer Hart.
Ayun, hello.
Pauwi na kasi ako galing sa Rizal.
Oo nga, maraming salamat for staying.
Yeah, very supportive yan.
Opo, napakaswerte namin.
Si Patrick, nakin Armand yata to.
Have REC.
Tsaka ano pala, pwede niyong gamitin yung logo ng PRC provided merong isang board o kaya lahat ng board. So, ibig sabihin, if you want some support na nakalagay yung logo ng PRC, papayagan kayo provided merong board. Yun yung arrangement namin with the commission. So, pwede niyong gamitin in cooperation with PRC, basta merong kasamang board. Pag walang kasamang board, don't use yung logo ng PRC at baka tayo ma-question dyan. Pero kung may kasamang board, pwede niyong gamitin. So, ano lang, sa inyo ko lang sinabi yun. Sa iba, hindi ko sinasabi yun. Kasi I got clearance from the commission na pwedeng gamitin yung logo ng PRC basta may kasamang board.
Okay.
Noted po. Engineer pa.
Engineer Donna, yung camera. Hindi ko nakikita.
Ano? Kita ko kayo.
Oo, hindi ka namin kita.
Hindi niyo kita. Screenshot ko. Smile! Ayan. Wait lang. Isa pa po. Smile ulit. 1, 2, 3. Ayun. Thank you.
Thank you po.
Nakunang ba lahat yung participants na 90? Ilan to? 92?
Hindi. Yung
lagpas mo po kanina.
100.
Oy. More than 100. Parang 107.
107.
plus po.
Okay.
Plus viewers po natin sa FB na nasa 70.
Plus yung sa FB pa.
Okay.
Ayun, magandang gabi po sa inyo.
Next time around, pwede nyo ilagay yung logo ng logo ng PRC doon sa yung pinalas nyo. Provided
Opo.
meron kayong merong board. Kahit na isa lang sa amin siguro.
Kahit isa.
Kahit si chairman o kaya si Rico. So pwede niyo ilagay.
Hermi rin pwede.
Medyo nahihirapan akong magpalipat-lipat. Medyo maraming Kanina medyo habol ng habol eh. Anyway, sige pagka libre pwede naman.
Thank you so much po.
Maraming salamat po ulit sa inyong lahat.
Thank you.
Okay.
Good
Thank you
night.
so much.
Good night po.
Okay.
Night.
Ito'y maling akala, isang malaking sablay. Pasensya ka na sa mga kathang isip kong ito. Wari dala lang ng pagmamahal sa'yo. Ako'y gigising na sa panaginip kong ito, at sa wakas ay kusang lalayo sa iyo, lalayo sa kabilis nagsimula